What if I told you that right now, in this very moment, countless versions of you are living out every possible path your life could have taken? Somewhere, you took that job offer you declined. Somewhere else, you married a different person, moved to a different country, made a different choice at a pivotal instant. This isn't just a daydream or the plot of a sci-fi movie. It's a legitimate scientific hypothesis known as the multiverse, and it's one of the most thrilling and controversial ideas at the frontier of human knowledge. For centuries, we've looked up at the night sky and wondered if we're alone in the cosmos. But what if the question is even bigger than that? What if ours isn't the only cosmos? The multiverse theory proposes that our universe, with all its galaxies, stars, and the story of us, might be just one page in an infinite book of realities. Each universe could have its own laws of physics, its own history, its own version of what's possible. Some might be almost identical to ours, with continents shaped just slightly differently or loved ones still alive. Others could be so alien, so unrecognizable, that matter itself behaves in ways we can't even imagine. This idea pulls us right to the edge of science, philosophy, and pure wonder, forcing us to rethink everything from the nature of time to the meaning of identity. In this video, we're going to take a deep and thoughtful journey into the heart of this astonishing concept. We'll trace its origins from ancient philosophy to modern quantum mechanics, hear from the brilliant minds who dared to propose it, and weigh the arguments both for and against its validity. We'll explore not just the science, but what it means for us, for our choices, our regrets, our sense of self in a possibly infinite sea of selves. This is more than a documentary. It's an invitation to expand your mind, to look at reality through a completely new lens. So get comfortable, open up your curiosity, and let's begin. To grasp the truly staggering scale of what we're discussing, we first need to shift our entire perspective on what everything even means. For most of human history, our concept of the cosmos was limited to a single, vast, but ultimately singular universe, the one containing our Milky Way galaxy, the distant quasars we observe, and the entire expanse of everything born from the Big Bang. But the multiverse theory fundamentally challenges that notion. It proposes that this entire, magnificent expanse of space and time, stretching over 93 billion light-years across and filled with perhaps 2 trillion galaxies, might not be the entirety of existence. Instead, it could be just one single component, one individual reality in a much grander, perhaps infinite, collection of universes. Think of it like this. Imagine you're standing in a room. This room is your entire reality. It's everything you've ever known, with its own specific set of rules, the way gravity works, the speed of light, the very forces that hold atoms together. Now imagine that your room is actually just one room in an impossibly immense, endless hotel. Every other room in this hotel is its own self-contained universe. Some rooms might look almost identical to yours, with furniture arranged just slightly differently. Other rooms could be filled with water, or have an entirely different color of light, or operate under physical laws where time runs backward or gravity is repulsive. This is the essence of the multiverse concept. Our observable cosmos is not the entire building, it's just our specific room. Scientists and philosophers use the term multiverse as an umbrella concept for several different models, but they all share this core idea of a reality beyond our own cosmic horizon. It's crucial to understand that these aren't just faraway planets or other dimensions within our universe. We're talking about completely separate space-time continua, each with their own potentially unique history and fundamental constants. The force of gravity, the mass of an electron, the number of spatial dimensions, these are the settings that define how a universe behaves. In our universe, these settings are perfectly tuned to allow for galaxies, stars, planets, and life to form. But in the multiverse framework, this fine-tuning might not be a miraculous coincidence. It could simply be a result of probability. With an infinite number of universes, every possible combination of physical laws and constants will exist somewhere. We, of course, find ourselves in one of the universes where the conditions are just right for us to be here to observe it. This idea doesn't just push the boundaries of cosmology. It completely shatters them, inviting us to reconsider not only the scale of reality but its very nature. It moves us from a universe to a multiverse, a transition as profound as when we realized the Earth was not the center of the solar system, or that the Milky Way was not the only galaxy. It's a foundational shift that sets the stage for everything to come, from the quantum mechanics that might spawn new worlds with every decision to the cosmic inflation that could be blowing bubbles of reality into existence even now. While our modern conception of the multiverse is often tied to complex equations and cutting-edge telescopes, the yearning to imagine realities beyond our own is a thread woven deeply into the fabric of human thought for millennia. This intellectual journey begins not in a laboratory, but in the ancient world, where philosophers used reason and observation to probe the deepest mysteries of existence. In the 5th century BC, the Greek philosopher Democritus, with his teacher Leucippus, developed a revolutionary idea that everything in the cosmos was composed of tiny, indivisible particles called atoms, moving through an infinite void. From this foundation, he took a breathtaking leap of logic. If the void is truly infinite and atoms are infinite in number, then their random collisions and combinations must inevitably produce not just our world, but a limitless plurality of worlds. He envisioned these worlds coming into being and passing away, some devoid of life or moisture, others, like our own, teeming with it. This was a staggering proposition that our entire reality was just one accidental arrangement in a cosmic sea of endless possibilities. For its time, it was a profoundly radical and naturalistic view of the cosmos, completely divorced from the whims of gods, and it planted a seed that would lay dormant for centuries, waiting for science to provide the tools to explore it further. This seed of thought persisted through the ages, often finding expression in metaphysical and theological contexts. Fast forward to the late 19th century, and we find the American philosopher and psychologist William James coining the actual term multiverse in an 1895 lecture. For James, the concept wasn't about quantum mechanics or bubble universes, but rather a way to grapple with a philosophical problem. He was arguing against a single, block universe where all events are predetermined, a notion he felt was stifling. By proposing a multiverse, he meant a universe that is not a closed, monolithic system, but one that is still in the making, open to genuine novelty, chance, and multiple potential outcomes. He used the term to describe a pluralistic reality where different perspectives and possibilities could genuinely coexist. This was a crucial step, moving the idea from ancient speculation into a more modern framework that wrestled with concepts of possibility, probability, and the open nature of the future. It was a philosophical bridge, setting the stage for the scientific revolution that was just around the corner. That scientific revolution arrived with the birth of quantum mechanics in the early 20th century, a field that would provide the first robust mathematical footing for these age-old speculations. As physicists like Niels Bohr and Werner Heisenberg developed the Copenhagen interpretation of quantum mechanics, they were left with a bizarre paradox. Particles seem to exist in a blurry cloud of all possible states, a superposition until the moment they are observed, at which point they seemingly randomly choose a single definite state. This notion of a wave function collapse triggered by observation struck some as unsatisfying and oddly human-centric. It was this very unease that led a young Princeton graduate student named Hugh Everett III to propose a shockingly elegant and to many unsettling alternative in 1957. Why not take the mathematics at its face value? Everett suggested that the wave function never collapses. Instead, every possible outcome of a quantum event actually occurs, but each outcome plays out in its own separate, non-communicating branch of reality. In this many worlds interpretation, reality continuously splits into a vast, ever-branching tree of universes, each one real and valid. With this theory, the ancient musings of Democritus and the philosophical pluralism of William James were suddenly reborn with the formidable language of physics. The concept of multiple worlds was no longer just a metaphysical thought experiment. It was a potential, direct consequence of our most successful scientific theory of the subatomic world. This rich historical tapestry shows us that the multiverse is not some fleeting modern fad. It is the culmination of a long, enduring human tradition of questioning the nature of our reality and daring to look beyond the immediate horizon of our own experience. From the atomic speculations of the ancients to the philosophical groundwork of the modern era, and finally to the rigorous, if mind-bending, equations of quantum physics, this journey demonstrates a fundamental aspect of our curiosity. We have always instinctively felt that our world might not be the only one, and that intuition, passed down through generations of thinkers, has finally found the scientific vocabulary to transform from poetic wonder into a legitimate and profoundly influential hypothesis about the fundamental structure of everything that exists. While the philosophical groundwork was fascinating, it took the strange and counterintuitive world of quantum mechanics to provide a concrete mathematical framework for multiple realities. To understand the revolutionary leap made by Hugh Everett, we first have to appreciate the puzzle he was trying to solve. In the early 20th century, physicists discovered that the subatomic realm doesn't play by the same rules as the world we see. A tiny particle like an electron doesn't have a single, definite location or state until we measure it. Instead, it exists in a blurry cloud of all possible positions and states simultaneously, a concept known as a superposition. The prevailing explanation, championed by giants like Niels Bohr and called the Copenhagen interpretation, said that this cloud of possibilities, this wave function, abruptly collapses into a single, definite reality the moment it is observed or measured. But this always left a deeply unsettling question. What exactly counts as an observation? Is it a conscious human, a machine? And why should consciousness have such a privileged, magical role in shaping reality itself? This was the intellectual climate when a brilliant and unconventional young PhD student named Hugh Everett III arrived at Princeton University. In 1957, Everett presented his doctoral dissertation, offering a radical and breathtakingly simple solution to this quantum conundrum. He proposed that we should take the mathematics of quantum mechanics at its absolute face value. There is no mysterious collapse of the wave function, he argued, because every single possible outcome encoded within that wave function actually happens. The reason we only perceive one outcome is that our own reality branches along with the particles. Imagine a quantum event with two possible outcomes, like a single electron hitting a detector and being deflected either left or right. In the Copenhagen view, it randomly picks one. In Everett's many worlds view, the entire universe splits in two. In one new universe, the electron goes left and you observe it going left. In the other, completely separate and equally real universe, the electron goes right and a version of you observes it going right. There is no single, privileged outcome. Both happen, each in its own newly created branch of reality. The key here is that these branches are decoherent. They don't interact or communicate with each other, which is why we, trapped on a single branch, are completely unaware of the others. Unsurprisingly, this idea was initially met with a combination of bewilderment, dismissal, and even hostility from the physics establishment, which was heavily invested in the Copenhagen view. The theory was so far ahead of its time that Everett himself became discouraged, largely leaving academia behind. For decades, his many worlds interpretation was seen as a bizarre footnote, the kind of far-out speculation that wasn't to be taken seriously. But as the decades passed, the persistent puzzles within quantum mechanics refused to go away, and a new generation of physicists began to re-examine Everett's work. They started to see its profound elegance. It removed the arbitrary division between the quantum world and the classical world of observers. It eliminated the need for a special collapse rule, making the theory more parsimonious. It provided a compelling, if staggering, explanation for the famous paradox of Schrödinger's cat, suggesting the cat is never both dead and alive in a box, but rather that the box's opening triggers a branching into one universe with a live cat and another with a dead one. The theory has since gained significant traction, not as proven fact, but as a powerful and coherent framework that many leading cosmologists and quantum physicists now consider to be the simplest interpretation of the mathematics. Beyond the equations, the many worlds interpretation forces us to confront dizzying questions about our own existence. If every quantum event spawns new universes, then an astronomical number of branches are being created every nanosecond. Somewhere in a universe almost identical to this one, you are reading this sentence but you decided to wear a different color shirt today. In another, you took a different route to work this morning and had a conversation that never happened here. In others, the differences are vastly more profound worlds where dinosaurs never went extinct, or where you never existed at all. This challenges our deepest intuitions about causality, identity, and free will. If every possible action is taken by some version of you, does choice lose its meaning? Are those other versions truly you, or are they separate individuals who simply shared a common past? There are no easy answers, but Everett's revolutionary idea gives us a terrifying and magnificent new lens through which to ask the oldest questions about who we are and the nature of the reality we inhabit. While the quantum many worlds interpretation deals with reality branching at the microscopic level, there is a parallel and perhaps even grander cosmological theory that paints a picture of multiple universes on an unimaginably vast scale. This idea doesn't originate in the fuzzy world of particles, but in the very first moments of our universe's birth, and it's known as cosmic inflation. To understand it, we need to rewind time to a fraction of a second after the Big Bang. The Standard Model had trouble explaining why our universe appears so remarkably uniform and flat across distances that seemingly could never have been in contact with each other. It was like walking into a room where 1,000 people who had never met or communicated were all wearing the exact same outfit and humming the exact same tune. In the early 1980s, physicist Alan Guth proposed a brilliant solution: a period of exponentially rapid expansion, or inflation, that occurred in the universe's first fleeting instants. This inflationary surge would have stretched a tiny, homogeneous patch of spacetime smaller than a subatomic particle into our entire observable cosmos, smoothing out any wrinkles and setting the stage for the universe we see today. But the most mind-bending implication of inflation is that it might not be a one-time event that happened only in our past. The underlying quantum fields that drive this hyper-expansion may be eternal. According to this model, championed and expanded upon by physicists like Andre Linde, the process of inflation doesn't end everywhere at once. Instead, think of the inflating cosmos as a pot of water beginning to boil. In most of the pot, inflation is still happening, the water is still boiling. But every so often, in a random spot, a bubble forms. In our analogy, that bubble is a region where inflation has stopped. The energy that was driving the expansion is suddenly released, flooding that bubble with matter and radiation, and essentially creating a new, hot Big Bang, a new universe with its own distinct space-time, beginning to evolve according to its own rules. Crucially, the rest of the pot, the greater inflating background, continues its frantic expansion, spawning an endless number of new bubble universes over an infinite eternity. This is the breathtaking vision of the bubble universe multiverse. Each of these bubbles is causally disconnected from all the others, forever separated by oceans of ever-inflating space that expands faster than light can travel across it. And here's where the theory gets truly fascinating. The transition that ends inflation inside each bubble might not happen in exactly the same way every time. The specific properties of a universe, the fundamental constants like the strength of gravity, the mass of electrons, the number of spatial dimensions, could be determined by how that bubble formed. This means each bubble universe could have its own unique set of physical laws. Our universe, with its perfect balance of forces that allows for galaxies, stars, and life, is simply one bubble where the numbers came out right. Countless other bubbles might be stillborn, collapsing instantly into black holes or expanding so rapidly that matter never clumps together. Others could be stable but utterly alien, with such different physics that matter forms into structures beyond our wildest imagination. In this cosmic landscape, the fine-tuning of our universe is no longer a miraculous mystery. It becomes a form of cosmic selection bias. We exist in this particular bubble because it's one of the rare ones capable of supporting conscious life that can ask the question in the first place. This concept dramatically expands the multiverse from the quantum realm to a truly cosmological scale, offering a powerful, if speculative, framework that unifies the very large with the very small. It provides a potential physical mechanism for generating not just one universe, but an infinite plurality of them, each a separate experiment in physics. This idea has become a fertile ground for both scientific inquiry and profound philosophical debate, challenging us to consider our place in a reality that might be far grander and more strange than we ever dared to dream. If the quantum many-worlds interpretation gives us a branching tree of realities and eternal inflation offers a bubbling cosmic foam, then string theory provides perhaps the most mathematically rich and mind-bogglingly vast canvas for the multiverse yet conceived, a landscape of possibilities so enormous that the number 10 followed by 500 zeros doesn't even begin to capture its scale. The fundamental ambition of string theory is to be the theory of everything, a single framework that seamlessly unites the world of the very large, governed by Einstein's general relativity, with the world of the very small, ruled by quantum mechanics. Its core, elegant idea is that the most basic building blocks of nature are not point-like particles but incredibly tiny, vibrating strings. Just as a single violin string can vibrate at different frequencies to produce every possible musical note, these fundamental strings vibrate in different modes to produce every different kind of particle we observe: electrons, quarks, photons, and all the rest. The specific vibration pattern determines the particle's properties, like its mass and charge. But for this beautiful mathematical symphony to work, the equations of string theory require something our everyday experience doesn't prepare us for, more than the three spatial dimensions of length, width, and height that we move through. The theory only remains consistent in a universe with a total of 10 or 11 dimensions. So where are these extra dimensions? The leading idea is that they are compactified, or curled up into a space so infinitesimally small that they are completely hidden from our perception. Imagine a long, thin garden hose. From a great distance, it looks like a simple one-dimensional line. But if you were an ant crawling on its surface, you would discover a second, circular dimension curled around the hose's circumference. In string theory, our entire three-dimensional universe could be like the length of that hose, while the other 6 or 7 dimensions are curled up into a complex, microscopic shape at every single point in space. And here is where the concept of the landscape truly unfolds. There isn't just one way for these extra dimensions to curl up. Physicists have discovered that the mathematics allows for a truly astronomical number of different possible stable shapes, each with its own unique geometry. And the specific geometry of this hidden, compactified space isn't just a mathematical curiosity. It directly determines the physics of the macroscopic universe it creates. The way the dimensions fold and twist dictates the number of particle families, the strength of fundamental forces like gravity and electromagnetism, the mass of the electron, the value of the cosmological constant, essentially every single fundamental constant and law that makes our universe what it is. Each distinct compactification creates a universe with a unique and self-consistent set of physical laws. Current estimates suggest the number of these possible stable configurations is around 10 to the power of 500. That's a 1 followed by 500 zeros, a number so colossal that it dwarfs the number of atoms in our entire observable universe. This is the string theory landscape, a vast, theoretical terrain of possible universes, each with its own physics. In this framework, our universe is not special or unique. It is simply one point in this impossibly huge landscape, one particular arrangement where the numbers happen to come out right for galaxies, stars, planets, and life to form. The profound fine-tuning we observe is no longer a puzzle requiring a designer. It becomes a form of environmental selection. We could not possibly find ourselves in a universe that is a barren, lifeless vacuum or one that collapses instantly. We can only exist in one of the rare Goldilocks-style universes where the constants are just right, and we simply got lucky in the cosmic lottery. This provides a powerful, naturalistic explanation for why our universe appears so perfectly tailored for life, anchoring the multiverse concept in the deep, albeit still unproven, mathematics of our most ambitious attempt to understand the fundamental nature of reality itself. So if an infinite number of universes exist with every conceivable set of physical laws, we are immediately faced with a profound and deeply personal question. Why does our universe seem so perfectly, almost miraculously, set up for life? The strength of gravity is precisely calibrated to allow stars to form and burn for billions of years. The cosmological constant, which governs the expansion of the universe, is fine-tuned to an astonishing 1 part in 10 to the 120th power, a number so unimaginably precise that it's like hitting a bullseye on a dartboard that spans the entire observable universe. If any of these fundamental constants were even slightly different by a fraction of a percent in some cases, the universe would be a barren, lifeless void. Atoms would never coalesce, chemistry would be impossible, and the cosmos would be a dark, empty expanse of nothingness. This apparent perfection is what scientists call the fine-tuning problem, and for a long time, it was seen as one of the most compelling arguments for a divine creator or some form of intelligent design. How else could we explain such incredible, life-friendly luck? The answer, emerging from the multiverse framework, is a concept known as the Anthropic principle. It's a simple idea with staggering implications. The word anthropic comes from the Greek word for human, anthropos, But the principle isn't just about us. It applies to any form of conscious, observing life. In its most basic form, the anthropic principle simply states that the universe we observe must be compatible with the existence of observers. We could not possibly find ourselves in a universe that is incompatible with life, because if it were, we wouldn't be here to talk about it. It sounds almost tautological, like saying, we see things because we are here to see them. But when you place this logic within the context of a vast or infinite multiverse, it transforms from a trivial statement into a powerful explanatory tool. Imagine you are a fish born in a pond. You might look around at the water, the plants, the temperature, and marvel at how perfectly suited this environment is for fish life. The water has just the right salinity, the pH is perfect, the temperature is ideal. You might conclude that this pond must have been meticulously designed for fish. But what you don't see are the thousands of other ponds nearby that dried up or froze solid or became toxic. You don't see them because you can't be in them. You can only exist in the one pond that, by pure chance, has the conditions necessary for you to swim, breathe, and exist. Your observation is biased by your very existence. You are a participant in a profound selection effect. This is exactly our situation with the universe. We are not observing a universe that was magically fine-tuned for us. We are observing a universe that had to be fine-tuned for us. Otherwise, we wouldn't be here to observe it. In a multiverse containing every possible combination of physical constants, it is statistically inevitable that a few universes will, by pure random chance, have the winning ticket. And we, of course, live in one of those winners. This shifts the entire scientific and philosophical conversation. We stop asking, why is our universe so special? And start asking, why do we perceive it as special? The fine-tuning isn't evidence of a plan, it's evidence of a filter. Our presence automatically filters out all the universes that don't meet the criteria for our existence. The anthropic principle doesn't explain why the multiverse exists, but it does provide a powerful and elegant explanation for why our particular corner of it looks the way it does. It's a Copernican revolution for the modern age, reminding us that while we may not be at the center of the cosmos, our perspective is irrevocably tied to the conditions that allowed us to evolve and look up at the stars in wonder. It blends hard physics with deep philosophy, forcing us to confront the fact that our observations are never truly objective. They are always and forever viewed through the lens of our own unlikely existence. This staggering vision of infinite branching realities doesn't just challenge our scientific models, it strikes at the very core of our philosophical understanding of who we are. If every quantum event, every random fluctuation, and every conscious decision spawns a new universe where a different outcome plays out, then the concept of a single, continuous self begins to unravel. We are forced to ask a deeply unsettling question. In a multiverse where countless versions of you are making every possible choice, what exactly constitutes your identity? Are these branching selves all equally you, simply experiencing different timelines, or are they fundamentally distinct individuals who merely shared a common past up until the moment of divergence? This isn't just an abstract puzzle. It has profound implications for how we view our lives, our choices, and our sense of agency. Consider a simple, everyday decision, like choosing to take a different route to work one morning. According to the many worlds interpretation, that single moment of choice doesn't just lead to one outcome. It creates at least two new universes, one where you took your usual route and had an ordinary commute, and another where you took the detour and perhaps witnessed a minor accident, causing you to be 5 minutes late. In that moment of divergence, two new versions of you are born. They both share an identical memory of waking up, having breakfast, and leaving the house. But from that point forward, their experiences and therefore the memories that shape their consciousness begin to diverge. As these small branchings accumulate over a lifetime, the person in another universe might become someone you would barely recognize, with a completely different set of experiences, relationships, and beliefs. This challenges the very notion of a stable, singular identity. We like to think of ourselves as a continuous narrative, a story that unfolds from birth to death. The multiverse suggests instead that you are more like a constantly forking path, a bundle of potentialities that is actualized in countless different ways across reality. This fragmentation of the self leads directly to one of the most contentious debates in modern philosophy, the nature of free will. If every possible action is taken by some version of you in some universe, does that mean your choices are meaningless? One perspective could be a form of radical liberation. If every path is taken, then there is no such thing as a wrong choice in the grand scheme of things. The version of you that chose to leave a stable job to pursue art is living that life somewhere, just as the version that played it safe is still in the office. This could, in theory, alleviate the anxiety of decision-making, knowing that no possibility is permanently lost. However, the flip side is deeply troubling. If all outcomes are realized, then the concept of free will, the idea that we are genuine authors of our actions, seems to evaporate. Your feeling of making a choice might be an illusion. The universe is simply actualizing all options, and your conscious experience is just passively riding along one specific branch. This is a modern incarnation of determinism, but on a cosmic scale. It suggests that rather than having free will, we are experiencing a predetermined script. It's just that every possible script is being performed simultaneously on the infinite stage of the multiverse. This, in turn, throws our entire framework of moral responsibility into question. Our systems of ethics, justice, and praise and blame are built on the foundation that individuals are agents who could have chosen differently. We hold someone morally accountable for a crime because we believe they had the free will to not commit it, but in a multiverse there is no could have. There is only did in another branch. Every conceivable action is performed by some version of every person. So is it fair to punish one version of a person for an action that another version refrained from? Does the existence of a universe where you are a hero make you less praiseworthy in this universe where you might have acted with cowardice? These questions aren't just theoretical, they force us to re-evaluate the very bedrock of our social and legal structures. The multiverse doesn't provide easy answers, but it magnificently amplifies ancient philosophical dilemmas about fate, chance, and the weight of our decisions, reminding us that our search for meaning is conducted within a reality of breathtaking complexity. What's truly fascinating is that this urge to envision a reality beyond our own is not a new invention of modern physics. It is a profound and recurring theme that echoes through the myths, stories, and spiritual traditions of virtually every culture across human history. Long before Everett or Goethe put equations to paper, our ancestors were using the language of gods and heroes to explore the very same concept of multiple, coexisting realms. This reveals something fundamental about the human psyche. We have always instinctively sensed that our world might not be the only one, and our oldest stories are a testament to that deep-seated curiosity. Consider the vast and intricate tapestry of Hindu cosmology. For thousands of years, ancient texts like the Puranas have described a universe that is cyclical, immense, and layered with multiplicity. The concept of loka refers to different planes or realms of existence, often described as 14 worlds, 7 upper worlds, and 7 lower worlds, each inhabited by different beings, from deities and humans to demons and ancestors. But it goes even further. time itself is seen as cyclical, with our universe going through endless phases of creation, preservation, and dissolution over epochs lasting billions of years. And most strikingly, our entire universe, with all its lokas and cycles, is not seen as unique. It is just one of countless such universes, sometimes described as bubbles floating in a great ocean or like seeds on the skin of a pomegranate, each governed by its own Brahma or creator. This vision of an infinite, cyclical multiverse, born from spiritual insight millennia ago, bears a stunning and poetic resemblance to the modern scientific model of eternal inflation and bubble universes. Traveling across the globe and into the cold north, we find another powerful example in Norse mythology. Here, the cosmos is structured as Yggdrasil, the immense world tree. Its branches and roots connect 9 distinct worlds, each a separate reality with its own inhabitants and rules. There's Midgard, the world of humanity, and Asgard, the realm of the Aesir gods. But there is also Jotunheim, the land of the giants, Svartalfheim, the home of the dwarves, and Alfheim, the world of the light elves. These are not just different countries on the same planet. They are fundamentally different dimensions of existence, accessible only through specific magical paths or bridges like the Bifrost. This concept of a multiverse of interconnected realms, each influencing the others and populated by beings with different natures and powers, reflects a worldview where multiplicity is woven into the very fabric of reality. It's a mythological expression of a pluralistic cosmos. These ancient narratives, while not scientific in the modern sense, serve a profound purpose. They are not merely primitive attempts to explain natural phenomena. They are explorations of existential themes that still resonate today, themes of destiny, identity, and the possibility of other ways of being. They provided a framework for people to understand their place in a vast and often mysterious cosmos, offering comfort, meaning, and a sense of connection to something greater than their immediate surroundings. The fact that so many disparate cultures, from the indigenous Dreamtime stories of Australia to the multifaceted spirit worlds of various African and Amerindian traditions, independently arrived at concepts of layered or parallel realities, suggests that this idea is a fundamental product of human imagination and contemplation. This rich history of mythological multiverses does not compete with the scientific theory. Instead, it enriches it. It shows us that the drive to look beyond the horizon of our own existence is a timeless human impulse. Our ancestors gazed at the stars and told stories of other worlds. Today, we gaze at the equations of quantum mechanics and the data from our telescopes and tell a new, evidence-based story. But the core wonder is the same. This beautiful parallel between ancient wisdom and modern speculation creates a bridge across time, reminding us that our quest to understand the totality of reality is a continuous, evolving human journey, one that connects the shamans and storytellers of our past with the physicists and philosophers of our present. For all its grandeur and explanatory power, the multiverse concept faces a formidable and fundamental challenge from the very methodology that birthed it, the scientific principle itself. The core of the scientific method is built on testability and falsifiability, the idea that a hypothesis must make predictions that can, in principle, be proven wrong through observation or experiment. If a theory is constructed in such a way that no evidence could ever disprove it, then it risks stepping over the line from science into the realm of pure philosophy or even pseudoscience. This is the central thrust of the criticism leveled against multiverse theories by many prominent scientists and philosophers. The problem is starkly simple. By their very definition, these other universes are proposed to be causally disconnected from our own. They exist in their own separate spacetime bubbles, with no possible transfer of information, energy, or signals between them and us. If we can never interact with them, never observe them, and never receive any data from them, then how can we possibly claim their existence is a scientific fact? Renowned physicist Paul Steinhardt, a critic of the multiverse, has argued that accepting such an untestable idea is a dangerous theory of anything because it can explain everything. It ultimately explains nothing, and it risks halting the search for deeper, more fundamental explanations for the properties of our own single, observable universe. Proponents of the multiverse, however, are not without counterarguments. They suggest that while we may never directly observe another universe, we might find its fingerprints or indirect signatures within our own. One of the most discussed possibilities lies in the afterglow of the Big Bang itself, the cosmic microwave background radiation. This faint microwave static that fills the sky is a baby picture of our universe, and it contains tiny fluctuations in temperature. Some models of cosmic inflation predict that if our universe collided or gravitationally interacted with a neighboring bubble universe in the distant past, that colossal event could have left a peculiar, anomalous pattern or a bruise in the CMB. Scientists have actively searched for such signatures, and some have even claimed to have found candidate anomalies, like the controversial cold spot, though these remain far from confirmed and could have more mundane explanations. Another avenue involves the search for gravitational waves from the inflationary epoch, which could carry information about the physics that drives the multiverse-generating mechanism. Furthermore, in the quantum many-worlds interpretation, some physicists speculate that under extremely specific conditions, faint interference between branches might be possible, leaving a detectable, if incredibly subtle, signature in certain quantum experiments. These are all long shots, and critics are quick to point out that such evidence would still be indirect and open to interpretation. It wouldn't be the same as definitively proving another universe exists. This debate ultimately forces a profound and necessary conversation about the very boundaries of science. What do we do with ideas that are mathematically elegant, that solve deep philosophical puzzles like fine-tuning, but that currently lie beyond our empirical grasp? Is it valid to pursue them as scientific theories, or should they be classified as stimulating metaphysical speculations? This tension is not new in the history of science. Ideas like the atom or continental drift were once considered untestable speculation before technology and ingenuity found ways to validate them. The multiverse may represent a new frontier, pushing us to expand our definition of what constitutes evidence. Perhaps it requires a new kind of science, one based on explanatory power and mathematical consistency when direct observation is impossible. Or perhaps its critics are right and it is a bridge too far. This ongoing, healthy conflict is not a weakness but a strength of the scientific process, a vital check on our imagination that ensures our most fantastic ideas about the cosmos remain grounded in the rigorous pursuit of verifiable truth. This leads us directly to one of the most profound puzzles in all of science, the fine-tuning problem. It's the startling observation that our universe appears to be almost miraculously calibrated for life. The fundamental constants of nature, the precise strength of gravity, the exact mass of an electron, the specific value of the force that holds atomic nuclei together, are set to such unimaginably precise values that even the tiniest deviation would make our existence impossible. If the strong nuclear force were just 2% stronger, for instance, hydrogen would fuse so rapidly in the early universe that stars would burn out in a cosmic blink, leaving no time for planets to form or life to evolve. If it were 2% weaker, heavy elements necessary for complex chemistry would never be forged in stellar furnaces. The cosmological constant, which governs the expansion rate of the universe, is fine-tuned to an accuracy of 1 part in 10 to the power of 120. That's a number so incomprehensibly precise it's like hitting a single, predetermined atom in the entire observable universe with a blindfolded dart throw. For a long time, this incredible precision was seen by many as the strongest argument for a divine creator or some form of intelligent design, a piece of evidence that our cosmos was purpose-built for beings like us. The multiverse concept offers a powerful and purely naturalistic alternative to this theological conclusion. It reframes the question from why is our universe so perfectly tuned to what would we expect to observe given that we exist. This is the essence of the anthropic principle in action. If the multiverse is real, if there are indeed an infinite or near infinite number of universes, each with its own randomly selected set of physical laws and constants, then it becomes a statistical certainty that a handful of those universes will, purely by chance, have the winning combination of numbers that allows for complexity, chemistry, and consciousness. We, of course, find ourselves in one of those fortunate universes. We couldn't possibly observe a universe that is barren and lifeless because, by definition, there would be no one there to do the observing. The apparent fine-tuning is therefore not evidence of a designer, but rather a profound form of selection bias. We are like a lottery winner marveling at their incredible luck while ignoring the millions of other tickets that were printed and lost. Our universe isn't special, it's just the one we happen to inhabit. This explanation is incredibly elegant from a scientific standpoint because it relies solely on the laws of probability and requires no supernatural intervention. It aligns perfectly with a worldview that seeks to explain nature through natural causes. However, this proposed solution is not without its own philosophical drawbacks, and it sparks intense debate. Critics argue that the multiverse explanation doesn't so much solve the fine-tuning problem as it simply shifts the mystery to a much larger and even more inexplicable scale. Instead of asking, why is this universe so finely tuned, we are now forced to ask, why does a multiverse with the capacity to generate all these possibilities exist at all? The existence of a universe-generating mechanism, be it eternal inflation or the landscape of string theory itself, requires explanation. Why does the underlying physics allow for such a prolific and varied reality factory? Some philosophers and scientists find this to be an unsatisfying retreat into a deeper, more abstract mystery, a kind of infinite regress where the ultimate answer to why is always pushed one step further away. Furthermore, this naturalistic explanation can feel existentially cold to some. The idea that our existence is the result of a colossal, random cosmic dice roll rather than a purposeful design can be a difficult pill to swallow. It places humanity in a vast, indifferent cosmos where we are not central players in a grand drama, but merely accidental inhabitants of a fortunate reality. Yet for others, this very same idea is a source of immense wonder and liberation. It suggests that our existence, however improbable, is a testament to the breathtaking creativity and sheer scale of nature. We are not the preordained goal of creation, but we are a beautiful and rare possibility that the cosmos has managed to actualize. The multiverse doesn't diminish our wonder at the universe's fine-tuning. It simply relocates that wonder from the specific constants of our reality to the magnificent, generative process that allows all possible realities to exist. It trades the mystery of a designer for the mystery of a truly infinite reality, leaving us to ponder whether that is a more satisfying or simply a more scientific form of awe. While the equations of physics provide the framework, it is through the vibrant lens of popular culture that the concept of the multiverse has truly exploded into the public consciousness. transforming from an esoteric scientific hypothesis into a shared modern mythology. Blockbuster franchises and visionary films have become the primary playground where we collectively explore the staggering implications of infinite realities, using the language of storytelling to make these abstract ideas feel personal, emotional, and thrillingly immediate. Perhaps no entity has done more to mainstream the multiverse than the Marvel Cinematic Universe, which has woven the concept directly into the core of its narrative fabric. In films like Spider-Man: No Way Home and the Doctor Strange series, we don't just hear about alternate realities, we see them. We witness different versions of beloved characters meeting, clashing, and collaborating. Tom Holland's Spider-Man sharing the screen with his predecessors, Tobey Maguire and Andrew Garfield, wasn't just a clever piece of fan service. It was a powerful, visceral demonstration of the many worlds idea. It made the theory tangible, allowing audiences to emotionally connect with the notion that a single event, like a radioactive spider bite, could ripple out into countless unique heroic journeys. These stories explore the weight of legacy, the pain of different choices, and the bittersweet reality that for every path taken, another was left behind. DC Comics has been exploring this territory even longer, with its iconic Crisis on Infinite Earths storyline serving as a foundational text for the pop culture multiverse. This narrative, which has been adapted into animated films and a major live-action television crossover, explicitly presents existence as a vast collection of parallel Earths, each with its own distinct history and familiar characters in unfamiliar roles. Here, we might see a world where Superman landed in Soviet Russia instead of Smallville, or where Bruce Wayne was the one who witnessed his parents' murder instead of becoming Batman. These explorations are more than just fun, what-if scenarios. They are profound inquiries into identity. They ask us to consider how much of who we are is defined by our core essence, and how much is shaped by the specific circumstances and traumas of our world. If a different set of events can create a villain out of a hero, or a hero out of a bystander, what does that say about the nature of good and evil itself? Yet, it was the independent film, Everything Everywhere All at Once, that delivered perhaps the most philosophically sophisticated and emotionally resonant take on the multiverse to date. This movie masterfully used the concept not as a backdrop for superheroics, but as a vehicle for a deeply human story about regret, meaning, and familial love. The protagonist, Evelyn, doesn't jump through dimensions to fight a cosmic threat. She does so to access the skills and memories of her alternate selves to save her struggling family and business. The film's genius lies in its absurdly hilarious yet poignant metaphor, the terrifying weight of infinite possibility, and the paralyzing anxiety of wondering if you made the right choices in life. The ultimate villain isn't a cosmic entity, but the nihilistic despair that can arise from seeing all your potential lives and believing that nothing matters. The film's breathtaking conclusion argues the opposite, that in the face of an infinite, chaotic multiverse, the choices we make and the love we share in this one singular universe are what create our own meaning and value. It's a message that brilliantly bridges the scientific and the spiritual. Of course, these popular interpretations take significant creative liberties. The idea of consciously jumping between universes or meeting your alternate self remains firmly in the realm of fantasy, a narrative device rather than a scientific proposal. The real quantum many worlds interpretation suggests these branches are forever separate and inaccessible. But this simplification is not a weakness, it is the very mechanism of popularization. By giving us characters to follow and emotional stakes to invest in, These stories act as a gateway drug for curiosity. They get audiences comfortable with the core conceit of multiple realities, making them more receptive to the actual science behind the spectacle. A teenager who leaves a Marvel movie might be inspired to look up Hugh Everett on their phone, sparking a lifelong interest in physics. A viewer moved by Everything Everywhere All at Once might find themselves contemplating the nature of choice and regret in a whole new light. Pop culture doesn't just entertain us with these ideas. It provides a shared vocabulary and a set of powerful metaphors that allow us all to participate in one of the most exciting conversations about the nature of reality itself. Yet this indispensable tool of imagination is often mistakenly seen as the opposite of science, a flight of fancy to be reined in by cold, hard facts. The truth is far more beautiful. The greatest scientific breakthroughs have almost always emerged from a powerful synergy between unshackled creativity and rigorous logic. Think of Albert Einstein, who as a teenager imagined himself riding alongside a beam of light, a thought experiment that eventually led him to the theory of relativity. He didn't start with a complex equation, he started with a vivid picture in his mind. In the same way, the multiverse did not spring fully formed from a set of calculations. It began as a speculative answer to a puzzling question, a what-if scenario that dared to take the mathematics of quantum mechanics or inflation to its ultimate, logical conclusion. The mathematical rigor came later as a way to test and formalize the initial imaginative leap. This process reveals that scientific progress is not a sterile, mechanical affair. It is a deeply human endeavor, fueled by curiosity and a willingness to dream big. The multiverse, in all its staggering grandeur, is as much a product of human ingenuity and creative courage as it is a set of hypotheses about cosmic inflation or quantum decoherence. This creative process is powerfully facilitated by the use of analogy and visualization, tools that allow scientists to translate impossibly abstract concepts into forms the human brain can grasp. We cannot picture 11 dimensions or an infinite branching tree of realities in a literal sense. So instead, physicists use metaphors. They talk about the multiverse as a bubbling pot of water, with each steam bubble representing a new universe. They describe the cosmos as a vast loaf of raisin bread baking in the oven, where each raisin is a galaxy moving away from the others as the dough expands. These are not mere simplifications for public lectures. They are crucial cognitive tools that researchers use to reason about their own work. A powerful analogy can reveal hidden connections, suggest new lines of inquiry, and help a scientist intuitively feel their way through a problem long before they can formalize it with mathematics. This is how imagination actively expands the frontiers of knowledge, by allowing us to explore possibilities that lie just beyond the edge of our current evidence, and to build scaffolds of understanding that can later be reinforced with data and deduction. Ultimately, the story of the multiverse underscores a vital lesson about the nature of discovery itself. The most profound questions about reality cannot be answered by data collection alone. They require us to first imagine what might be possible, to venture into the unknown armed not with proof, but with plausible speculation and creative thought. This willingness to entertain seemingly outlandish ideas that space could be curved, that time is relative, or that our universe is one of many, is what separates true innovation from mere incremental progress. It is this fearless embrace of imagination that allows science to continually reinvent our understanding of the cosmos, pushing us to look beyond the horizon of the known and venture into the breathtaking possibilities of what might be. But this breathtaking vision of infinite possibility forces us to confront a deeply unsettling ethical dilemma. If every conceivable action is taken by some version of you in some other branch of reality, does the choice you make in this universe truly matter? Does the very concept of moral responsibility begin to evaporate when every path, no matter how virtuous or vile, is realized somewhere in the cosmic tapestry? This is not just an abstract puzzle for philosophers. It's a question that strikes at the heart of how we live our lives and judge the actions of others. One compelling argument suggests that the multiverse could indeed foster a dangerous form of moral complacency. Imagine a person standing at a moral crossroads, contemplating a selfish or even harmful act. A twisted internal logic might emerge. Well, if I choose to do this, there's another universe where I made the better choice, so it doesn't really matter what I do here. All outcomes exist anyway. This line of thinking could be used to rationalize any decision, effectively dismantling our entire framework of ethics, which is built on the foundational belief that our choices have unique and significant consequences. It could lead to a kind of cosmic nihilism, where the weight of our actions feels diluted by the sheer scale of existence. Why strive to be good if a version of you is already perfectly good in another world? Why resist a temptation if another you is already giving in? This perspective sees the multiverse not as a liberation, but as a threat to the very notion of accountability that binds societies together. However, there is a powerful and completely opposite viewpoint that emerges from this same logic. Rather than diminishing our choices, the multiverse could be seen as magnifying their importance to an almost unimaginable degree. Every single decision you make isn't just creating one outcome. It is actively creating an entire new universe where that specific version of events unfolds for a new consciousness that shares your history. The you that chooses kindness in a moment of conflict isn't just making one person's day better. You are literally bringing into being a reality where that kindness ripples forward through time, influencing countless other lives in that branch. Conversely, the choice to act with cruelty creates a whole timeline where that pain and negativity becomes a permanent part of that universe's history. In this light, your agency is not reduced, it is exponentially amplified. You are not a passive rider on a single predetermined track. You are an active participant in the continuous creation of reality, constantly determining which of the infinite possible universes will actually be realized with you as its conscious center. This places an immense, even terrifying, weight on every single moment. There is no escape into the idea that another version of me is doing the right thing. In this universe, for this version of you, the responsibility is entirely and utterly yours alone. Your choices are what define the moral character of the reality you are personally experiencing and creating. This debate forces us to re-examine the very foundations of our legal and social systems, which are built on the concept of free will and the idea that individuals could have chosen differently. How would a justice system operate if it truly embraced the many worlds interpretation? Could we hold someone accountable for a crime committed in this branch, knowing that in a neighboring universe a version of them chose not to commit it? The multiverse framework challenges the classic notion of punishment and reform, potentially shifting the focus from retribution to a more nuanced understanding of the conditions that lead a particular consciousness down one branching path versus another. It invites a profound compassion, recognizing that the potential for both good and evil exists within everyone, and the specific circumstances of a universe might tip the scales. Yet it also demands rigorous personal accountability, emphasizing that within the confines of your own conscious experience, you are the sole author of your moral story. This isn't a question that physics can answer for us. It is an ethical fork in the road that humanity itself must navigate, using the multiverse not as an excuse, but as a mirror to reflect on the incredible power and consequence we wield with every thought, every word, and every action we take. This notion of branching realities and bubble universes might seem like the exclusive domain of theoretical physics, but you can find a strikingly similar concept powering the device you're likely using to watch this very video. The world of computer science and information technology provides us with some of the most powerful and intuitive metaphors for understanding the multiverse, framing these cosmic ideas not in the language of equations, but in the logic of code and computation. At its heart, the idea of parallel processing is a form of technological multiverse. Modern supercomputers don't solve complex problems one step at a time on a single processor. Instead, they break a massive problem down into smaller pieces and distribute them across hundreds or thousands of individual processing cores, each one working on its own part of the puzzle simultaneously. Each core is essentially operating in its own tiny, self-contained world of data, processing one possible outcome or solving one segment of the equation, all at the same time. The final result is then compiled from all these parallel streams of computation. This isn't just a loose analogy. It's a direct functional parallel to the quantum many-worlds interpretation, where reality itself is constantly forking into countless branches, each one processing a different possible outcome of every quantum event. This line of thinking leads us to one of the most provocative and debated ideas in modern philosophy, the simulation hypothesis, most famously articulated by philosopher Nick Bostrom. Bostrom's argument is a fascinating exercise in logical probability. He suggests that if a civilization ever reaches a sufficiently advanced technological stage, what we might call a post-human civilization, it would likely possess the computing power to run incredibly detailed, conscious simulations of its own ancestors or of other realities. If you accept that premise, then you are faced with a startling statistical possibility. The number of these simulated realities, or artificial multiverses, could eventually vastly outnumber the one single, original, base reality. Therefore, if such simulations are possible and are eventually created, the chances that we ourselves are living in one of those simulations, rather than in the original reality, are astronomically high. We could be characters in an unfathomably complex video game, our entire universe and all its history nothing more than lines of code running on some advanced civilization's computer. This idea, while seemingly ripped from science fiction, is taken seriously by a number of technologists and philosophers because it provides a potential, if unsettling, answer to the question of our existence that is rooted in a form of technological creation rather than a supernatural one. This perspective is deeply connected to a broader school of thought known as digital physics, or the concept of the universe as a cosmic computer. Proponents of this view propose that at the most fundamental level, the universe may not be made of tiny vibrating strings or particles, but of pure information. In this model, every particle, every force, every fluctuation of energy is ultimately a bit of data, and the laws of physics are the algorithms or the software code that governs how that information is processed and evolves over time. The universe computes its own future state based on its current state, following a set of immutable logical rules. This isn't to say that reality is literally made of silicon chips, but that the underlying structure of existence might be mathematically isomorphic to a computational process. If this is true, then the idea of a multiverse becomes almost trivial from a computational standpoint. Generating a near-infinite number of slightly varied universes is no longer a mysterious physical process requiring unimaginable energy. It's simply a matter of allocating more processing power and running the simulation again with different initial parameters or random seeds. The bubble universes of inflation theory become like different instances of a program running on a server, and the branching worlds of quantum mechanics become like a computer exploring all possible branches of a decision tree simultaneously to find an optimal solution. These technological metaphors are far more than just helpful simplifications. They represent a profound form of interdisciplinary thinking that enriches our understanding from all angles. They allow a computer scientist to look at a cosmic inflation model and see a familiar distributed computing problem. They allow a physicist to consider the nature of quantum superposition and see a form of natural parallel processing. By borrowing concepts from the world we have built, we can demystify the abstract wonders of the cosmos, using the logic of our own creations to shine a light on the possible logic of reality itself. This cross-pollination of ideas doesn't provide proof, but it opens up entirely new avenues for inquiry, suggesting that the fundamental fabric of the multiverse might be less like a material and more like a program, and that our entire existence might be part of a computation of literally cosmic proportions. Consider for a moment the mass of the proton. It is almost 2,000 times heavier than the electron that orbits it in every atom of your body. This specific ratio is not dictated by any fundamental law we know. It appears to be a random number set at the birth of our cosmos. Yet, if it were even slightly different, the consequences would be catastrophic for the universe as we know it. If the proton were just 0.2% heavier, it would become unstable and decay into other particles, dismantling the very building blocks of every atom and ensuring that no complex matter, and therefore no life, could ever form. This is not an isolated quirk. It is one of dozens of exquisitely precise numerical values that seem to conspire to make our existence possible. The strength of the force that holds atomic nuclei together, the rate of the universe's expansion, the exact amount of dark energy stretching the fabric of spacetime, each one is dialed in to a breathtakingly narrow, life-permitting range. From the perspective of a single universe, this looks less like a happy accident and more like a miracle. It feels as if the cosmos was purpose-built for us, a notion that has led some to invoke a divine architect or a supernatural fine-tuner. But what if we are looking at this puzzle from the wrong angle? What if we are not the intended recipients of a perfectly designed reality, but rather the inevitable inhabitants of a statistically inevitable outcome? This is where the multiverse concept reframes the entire conversation. In a single, solitary universe, the odds of all these constants randomly lining up to allow for stars, planets, and life are so infinitesimally small that they border on the impossible. It is like shuffling a deck of cards and getting them to return to perfect numerical and suit order every single time for eternity. The probability is so vanishingly small that it demands an explanation. However, if you shuffle that same deck an infinite number of times, the perfect order isn't just possible, it is an absolute certainty. It will happen not just once, but an infinite number of times. This is the profound shift in perspective offered by the multiverse. In an infinite or near-infinite ensemble of universes, each with its own randomly selected set of physical constants, it is no longer a miracle that one universe got the numbers right. It is a statistical guarantee. The overwhelming majority of universes will be stillborn or barren cosmic deserts where matter never clumps, or where atoms instantly fly apart, or where everything collapses into a black hole moments after creation. But a tiny, tiny fraction of universes will, by pure random chance, have the winning lottery ticket. And we, of course, can only find ourselves in one of those fortunate few. Our observation is biased by our very existence. We are a living example of a profound selection effect. Let's look at a specific, and perhaps the most famous, example of this fine-tuning, the cosmological constant, which represents the energy density of empty space, often called dark energy. When Einstein first introduced this constant, he later called it his greatest blunder, but modern astronomy has shown it to be very real and the dominant force governing the expansion of our universe. The observed value of this constant is positive but incredibly small. The mystery is not just its size but its precision. Theoretical physics suggests that the vacuum of space should be teeming with quantum energy, and that this energy should contribute to the cosmological constant at a level that is about 120 orders of magnitude. That's a 1 followed by 120 zeros larger than what we actually observe. If the value were anywhere near that theoretical prediction, the repulsive force of this dark energy would have been so powerful that it would have ripped apart every galaxy, star, and planet before they could even begin to form. Our universe would be a featureless, accelerating void. The fact that the observed value is so much smaller is the single most precise fine-tuning problem in all of physics. In a single universe scenario, this is utterly baffling, but in a multiverse it becomes expected. In the vast cosmic lottery, every possible value for the cosmological constant will be tried out. Universes with values too high blow themselves apart. Universes with values too low or negative collapse back in on themselves. Only the rare universes with a value very, very close to zero, like ours, achieve the delicate balance between expansion and contraction that allows for the multi-billion-year-long cosmic drama of structure formation and evolution to unfold. This elegant explanation, however, is not without its own philosophical price. It trades the mystery of a single, inexplicably lucky universe for the mystery of an unimaginably vast and profligate multiverse. Some critics argue that this is not a true explanation at all, but rather a sophisticated form of hand-waving that simply shifts the goalposts. Instead of asking, why is our universe so finely tuned, we are now forced to ask, why does a mechanism that generates an infinite number of universes exist? The existence of the multiverse-generating engine itself, be it eternal inflation or the string theory landscape, now requires an explanation. This can feel like an infinite regress, pushing the ultimate why question one step further away without ever truly answering it. Furthermore, this vision can feel existentially cold. It places us in a cosmos of unimaginable scale, but also of profound indifference. We are not special, we are just lucky. Our existence is not the goal of creation, but a random byproduct of a process that churns out mostly lifeless realities. For some, this diminishes the wonder. For others, it amplifies it. The fact that we are here at all, against such impossible odds, to ponder the very nature of our unlikely existence, becomes a story of incredible cosmic fortune. The multiverse doesn't erase the mystery of our fine-tuned universe. It relocates that wonder from the specific numbers on the dials to the magnificent, generative process that allows for all possible numbers to be tried. It is a story not of design but of selection, and it challenges us to find our meaning not in being the center of a planned creation, but in being conscious witnesses to a reality of breathtaking and perhaps infinite possibility. But this breathtaking vision of an infinite multiverse, brimming with every conceivable possibility, introduces a profound and deeply counterintuitive mathematical headache for physicists. It's known as the measure problem, and it essentially asks a deceptively simple question. In a reality where everything that can happen does happen, how do we decide what is likely and what is unlikely? How can we possibly assign probabilities to events when all outcomes are realized somewhere? This isn't just an abstract philosophical puzzle. It strikes at the very heart of whether multiverse theories can ever make testable predictions. Imagine you're trying to calculate the odds of flipping a fair coin and it landing on heads. In a single universe, it's straightforward, a 50-50 chance. But in the quantum many-worlds interpretation, every coin flip branches the universe. There is a universe for every single heads result, and a separate universe for every single tails result. If the multiverse is truly infinite, then there are an infinite number of universes where the coin landed heads, and an infinite number where it landed tails. How can you say that heads is 50% likely when the number of universes with that outcome is exactly the same as the number without it? Both are infinite, and mathematically, infinity divided by infinity is undefined. This is the core of the measure problem. We need a way to count these universes, or weigh their amount of reality to recover the sensible probabilities that we observe in our own world. Physicists have proposed several clever, though still controversial, frameworks to tackle this. One prominent approach is known as volume weighting, often applied to the eternal inflation model of bubble universes. The idea here isn't to count each universe as one equal unit, because an infinite number of them might be utterly barren and short-lived, while a smaller fraction are long-lived and complex like ours. Instead, we might assign a measure based on the physical volume of space-time that exhibits a particular set of properties. Perhaps we should consider the number of observers, or the amount of matter, or the duration of time that a certain condition exists within a given universe. The goal is to find a way to compare the sizes of different sets of universes within the infinite multiverse. Another approach borrows from Bayesian probability, a statistical method that deals with updating beliefs based on new evidence. In this view, the probability of a theory isn't a fixed frequency but a measure of our confidence in it. For the multiverse, a Bayesian might say that while all outcomes exist, we should assign a higher degree of belief to finding ourselves in a universe that is more typical within a given measure. The challenge, of course, is that there is no single, obvious, or agreed upon way to choose the correct measure. Different choices can lead to wildly different, and sometimes absurd, predictions. Without a solution to the measure problem, the predictive power of multiverse theories remains frustratingly ambiguous. It creates a scenario where the theory could potentially explain anything, and therefore, in a way, explains nothing. For instance, if we are trying to understand why the cosmological constant has its specific, tiny value, the multiverse offers an answer. It's because that value allows for observers like us. But if we cannot define a measure, we cannot predict what value a typical observer should see. We could just as likely find ourselves in a universe with a slightly different value, as long as it still permitted life. The measure problem is the essential gatekeeper that stands between the multiverse being a fascinating speculative idea and a robust, predictive scientific framework. Solving it requires a deep collaboration between cosmologists, quantum physicists, and philosophers, pushing the boundaries of our understanding of mathematics, probability, and the very nature of reality itself. It is a reminder that infinity is not just a concept of scale, but a labyrinth of logic that we are only just beginning to learn how to navigate. This relentless, eternal process of inflation completely rewrites our conventional story of cosmic beginnings and endings. We often picture the Big Bang as a singular, explosive moment that marked the start of everything: time, space, and matter all bursting forth from a single point. But in the framework of eternal inflation, our Big Bang was not the ultimate beginning. It was simply a local event, the moment when inflation stopped in our particular region of space-time, converting that incredible inflationary energy into the hot, dense soup of particles that would eventually become our universe. Meanwhile, the greater inflating background, the meta-universe if you will, continues its frantic expansion unabated, having no single point of origin and no foreseeable end. This suggests a cosmos that is fundamentally ageless and infinite, a reality without a true birthday or a final curtain call. Our entire cosmic history, from the first second to the eventual heat death trillions of years from now, is just a fleeting episode within an infinitely larger, eternal context. This grand vision inevitably shatters our most basic intuition about time itself, that it is a universal, linear river flowing inexorably from the past through the present and into the future. Eternal inflation presents a cosmos where time operates more like a vast, branching delta. Each new bubble universe represents a new tributary with its own potentially independent arrow of time. The direction of time's flow from order to disorder, which we perceive as an fundamental law of nature, might not be a universal constant at all. It could be an emergent property, a consequence of the specific low entropy conditions within our local bubble at the moment our Big Bang occurred. In other bubble universes, the initial conditions might have been completely different. We could imagine universes where the arrow of time points backward from our perspective, or where time is cyclical, with no clear beginning or end, endlessly repeating a sequence of expansion and contraction. Some universes might even be truly timeless, static realms where change is impossible, and the very concept of before and after has no meaning. The flow of time, so central to our experience of reality, could be a parochial feature of our local cosmic neighborhood, not a rule for the entire multiverse. This leads us to one of the most profound implications, the potential for a truly cyclical multiverse. Some cosmological models, like the conformal cyclic cosmology proposed by Roger Penrose, suggest that the distant heat-death future of our universe, a vast, cold, empty expanse filled with low-energy radiation, could mathematically become indistinguishable from the high-energy, ultra-dense state of a new Big Bang. In this view, the end of one universe literally becomes the beginning of the next in an endless, timeless cycle. When placed within the context of eternal inflation, this idea expands exponentially. Instead of a single cyclical universe, we could have an infinite foam of universes, each going through its own cycle of birth, evolution, and death, all embedded within the eternally inflating background. Our universe's entire lifespan, from its fiery beginning to its cold demise, would be just one heartbeat in an infinite body of cosmic cycles. Contemplating this challenges the very core of how we perceive reality and our place within it. It forces us to distinguish between the time we experience within our universe and the possibility of a meta-time, or perhaps a timeless state that exists in the greater inflating realm beyond our bubble. Our laws of physics, which depend so crucially on the forward march of time, might be mere local bylaws. The eternal, cyclical nature of the multiverse suggests a reality where creation is not a one-time event but an ongoing, endless process. We are not living in a universe with a definitive history and a fixed destiny. We are living within one momentary expression of an infinite, eternal reality that is constantly giving birth to new worlds, each with its own story of time. This perspective doesn't diminish our existence. Instead, it places our fleeting moment of consciousness within the most magnificent and expansive context imaginable, a never-ending tapestry of becoming. Yet for every bold leap of imagination, a necessary voice of caution urges us to pause and reflect. This is the domain of philosophical skepticism, which asks a profoundly important question. In our quest to explain the cosmos, are we making a genuine scientific discovery, or are we crafting an elaborate metaphysical escape hatch? The debate finds a fascinating focal point in the work of philosopher David Lewis, who championed a view called modal realism. Lewis argued that all possible worlds are just as real as our own. not merely as ideas or mathematical constructs, but as concrete, physical realities. For Lewis, a world where you decided to have toast instead of cereal for breakfast this morning isn't a fiction. It's a genuine place, causally isolated from us, where a counterpart of you is crunching on cornflakes right now. His reasoning was based on a desire for philosophical parsimony. He believed it was simpler and more logically consistent to take our talk about possibilities at face value, to believe that when we say, "It's possible that dinosaurs never went extinct," we are actually referring to a real, existing universe where that is true. This framework provides a sturdy philosophical foundation for the multiverse, suggesting that these other realms aren't a bizarre addition to reality, but an intrinsic part of its fundamental structure. However, this very stance highlights the core of the skeptic's critique. Lewis's possible worlds are, by his own admission, causally disconnected from our own. We cannot interact with them, observe them, or receive any signal from them, and this is where the line between science and metaphysics begins to blur. A central tenet of the scientific method is falsifiability, the idea that a theory must make predictions that could, in principle, be proven wrong by some conceivable experiment or observation. If a theory is constructed in such a way that it is immune to any possible evidence that could count against it, then it risks stepping outside the bounds of empirical science. Prominent critics like physicist Paul Steinhardt argue that certain multiverse models do exactly this. If we cannot ever access these other universes, if their existence is permanently hidden behind an impenetrable veil, then positing their existence becomes an exercise in speculation rather than discovery. It becomes what philosophers call an ad hoc explanation, a solution invented purely to save a theory from a difficult problem, like the fine-tuning of our universe, without offering any new, testable predictions of its own. The skeptic worries that by invoking an infinite number of invisible universes, we might be giving up on the search for a deeper, more elegant explanation for why this universe is the way it is. This tension creates a vital and healthy dialogue between scientific ambition and philosophical rigor. It forces us to carefully consider the rules of the game when we venture into such expansive territories. Is explanatory power alone sufficient, even in the absence of direct evidence? Does solving a profound puzzle like fine-tuning justify the introduction of entities we may never be able to observe? Or does this approach ultimately lead us down a slippery slope where the lack of constraints allows for almost any claim to be made? These questions don't have easy answers, but they are essential for maintaining the integrity of our quest for knowledge. They remind us that wonder must be tempered with discipline, and that our most exciting ideas about the cosmos must continually be held up to the light of critical scrutiny. This doesn't mean we should abandon multiverse theories, but rather that we must pursue them with a clear-eyed understanding of their strengths and their profound philosophical limitations, always striving to find that fragile balance between daring to imagine the impossible and demanding the rigor that turns imagination into understanding. Long before the equations of quantum mechanics or the models of cosmic inflation, storytellers and literary artists were using the power of narrative to explore the dizzying implications of multiple realities, crafting thought experiments that probe the very essence of identity, memory, and the paths not taken. Literature has always served as a vital testing ground for humanity's most radical ideas about existence, and the concept of the multiverse is no exception. Authors, unconstrained by the need for empirical proof, have been free to follow these concepts to their most profound and often deeply personal conclusions, giving us a rich emotional and philosophical vocabulary for an idea that science is still struggling to formalize. One of the earliest and most elegant literary explorers of this terrain was the Argentine master of metaphysical fiction, Jorge Luis Borges. In his seminal 1941 short story, The Garden of Forking Paths, Borges conceived of a labyrinth that is not a physical place, but a sprawling, branching novel that represents time itself. The book's central premise is that at every moment of decision, all possible outcomes occur simultaneously, each one giving rise to new futures that diverge and multiply without end. Borges's fictional Chinese philosopher, Tsui Pen, describes a universe where time forks perpetually toward innumerable futures, creating a web of causality where individuals are not singular beings but a multitude of selves, living out every possible destiny. This is a stunningly precise literary prefiguration of Hugh Everett's many worlds interpretation, conceived over a decade before the physicist presented his doctoral thesis. Borges wasn't interested in the quantum mechanics of it all. He was fascinated by the existential weight. His story suggests that in such a reality, we are both the authors and the subjects of an infinite book, our lives a single thread in a tapestry of unimaginable complexity, forcing us to confront a world where every choice is both made and unmade, and where regret is a meaningless concept because every possibility is, somewhere, fully realized. Moving into the mid-20th century, no author wrestled with the fractured nature of reality more obsessively than Philip K. Dick. For Dick, the multiverse was not an abstract philosophical concept but a visceral, often terrifying, lived experience. His seminal 1962 novel, The Man in the High Castle, presents a world where the Axis powers won World War II, a single, detailed, alternate history. But the novel's true genius lies in its meta-narrative, where characters become aware of their own reality's contingency by encountering artifacts from our world, such as a banned book that describes the Allied victory. This creates a dizzying hall of mirrors, forcing both the characters and the reader to question which timeline is the real one. Dick's work is saturated with this paranoia about the stability of the real. In stories like Flow My Tears, The Policeman Said, or Ubik, he explores realities that shift, decay, or are revealed to be artificial simulations. For Dick, the multiverse was a psychological and spiritual prison, a source of profound anxiety where the individual self could be erased or overwritten at any moment. His characters grapple with the trauma of realizing their entire lives might be based on a false premise, a theme that resonates deeply in our modern era of digital misinformation and deepfakes, making his work feel more prescient than ever. In contrast to Dick's paranoid vertigo, the contemporary author Ted Chiang approaches the multiverse with the calm, precise logic of a scientist and the deep empathy of a philosopher. His celebrated story, Anxiety is the Dizziness of Freedom, from the collection Exhalation, provides one of the most nuanced and technologically grounded explorations of the concept. Chiang imagines a world where a device called a prism allows limited communication between branching timelines, enabling people to literally converse with their alternate selves. This isn't used for superheroics or grand adventures. Instead, Chiang focuses on the intimate psychological consequences. He explores how this technology would amplify human anxiety, envy, and regret. Would knowing that a version of you made a better decision lead to self-loathing? Would seeing a self who is worse off foster a smug sense of superiority or a crippling fear of failure? Chiang uses the prism as a tool to dissect the human condition, arguing that the ability to see our roads not taken wouldn't liberate us, it would shackle us to a perpetual state of comparison and doubt. His work brilliantly illustrates that the true challenge of the multiverse may not be understanding the physics, but managing the profound emotional and ethical turmoil it would unleash upon our fragile psyches. The power of these literary narratives lies in their ability to do what pure science cannot. They place us directly into the emotional and ethical experience of these ideas. They provide a crucial bridge between abstract theory and human meaning, inspiring not only public fascination but also serious academic discourse. Philosophers cite Borges when discussing the nature of time. Cognitive scientists reference Dick's explorations of fabricated realities, and ethicists use Chiang's stories as case studies for the moral implications of new technologies. Literature prefigured the scientific multiverse not by providing blueprints, but by mapping the interior human landscape of such a reality, giving us the stories we need to navigate a cosmos that grows stranger and more wonderful with each new discovery. This brings us to one of the most perplexing and enduring puzzles in all of quantum mechanics, a concept that seems to elevate the act of observation from a passive process to a creative one. At the subatomic level, particles don't exist in a single, definite state until the very moment they are measured. An electron, for instance, isn't neatly orbiting a nucleus like a tiny planet. Instead, it exists as a cloud of probability, a superposition of all its possible locations, energies, and spins simultaneously. The orthodox Copenhagen interpretation, developed by Niels Bohr and Werner Heisenberg, states that this probability wave collapses into a single, concrete reality only when an observation is made. But this immediately raises a deeply strange question: what or who qualifies as an observer? Is it a conscious human being, a machine, a cat, or even a single-celled organism? The theory itself is silent on this crucial point, creating a bizarre scenario where the boundary between the physical world and conscious awareness becomes dangerously blurred, suggesting that reality might, in some fundamental way, be participant-dependent. This line of thinking was pushed to its most radical conclusion by the brilliant physicist John Archibald Wheeler, who proposed the idea of a participatory universe. For Wheeler, we are not merely passive spectators on a cosmic stage that was set long before we arrived. Instead, through the very act of observation and questioning, we become active participants in bringing the universe into being. He used a powerful metaphor he called the 20 questions universe, inspired by the parlor game. Imagine a game where the answer isn't predetermined. The first player can change the word they are thinking of with each new question, as long as it remains consistent with all the previous answers. In this version of the game, the final answer isn't discovered. It is created through the process of questioning itself. Wheeler suggested the cosmos operates in a similar way. The universe only acquires a definite history, a specific set of properties, in response to the measurements we choose to make. Our inquiries into the nature of reality are what force it to crystallize from a haze of possibilities into the solid, classical world we experience. In this view, the universe could not exist without conscious observers to give it meaning and form, a truly breathtaking inversion of our usual understanding of our place in the cosmos. Now, place this mind-bending concept within the framework of the quantum multiverse, and the implications become even more profound. If every quantum measurement doesn't collapse a wave function, but rather causes the entire universe to branch, then the role of the observer is transformed. We are not collapsing possibilities into a single reality. We are, in a sense, selecting which branch of reality our own conscious experience will continue to follow. With every observation, every measurement, every decision, your stream of consciousness navigates one specific path through the infinite, ever-branching tree of the multiverse. This doesn't mean you can consciously choose your destination like a cosmic tourist. The branching is governed by the probabilistic laws of quantum mechanics. But it does mean that your specific, subjective experience of reality is inextricably linked to the sequence of observations you make. You are not a puppet on a single string of fate, but an active participant whose attention and actions determine your personal journey through the vast tapestry of parallel worlds. Your consciousness is the needle weaving its unique thread through the infinite fabric of the multiverse. This inevitably plunges us into one of the most contentious and unresolved debates in all of modern science, the role of consciousness itself. Does consciousness cause the wave function to collapse, as some interpretations suggest, or is consciousness merely a phenomenon that emerges from a brain that itself is subject to the same quantum laws as everything else? The multiverse theory offers a way out of this conundrum by eliminating the need for a collapse altogether. In the many worlds view, there is no special role for consciousness. The branching happens regardless of whether a human, a machine, or a rock is involved in the interaction. Consciousness is simply what it feels like to be, a complex information processing system traveling along one specific branch. This is a more austere, physicalist interpretation that avoids placing consciousness on a mystical pedestal. However, it leaves us with the hard problem of consciousness. Why should any physical process, any branching of universes, be accompanied by subjective experience at all? Why aren't we all just philosophical zombies, complex automata going through the motions in a universe devoid of inner feeling? The multiverse may explain the mechanics of reality, but it doesn't yet explain the sensation of being. Ultimately, these explorations reveal that multiverse theories are far more than just speculative cosmology. They are a gateway into some of the most profound questions humanity has ever asked. They force a collision between physics and philosophy, between objective measurement and subjective experience. They challenge us to consider whether the universe is a pre-recorded movie we are simply watching, or an interactive story we are writing together with every glance and every experiment. The idea that observation could shape reality, whether through wave function collapse or branch selection, suggests a cosmos that is not static and separate from us, but dynamic and deeply intertwined with the presence of aware beings. It hints that the quest to understand the universe might not be a journey toward a distant, external truth, but rather a process of self-discovery, as we slowly unravel the ways in which our own minds are woven into the very fabric of all that is. This expansive view of reality fundamentally reshapes one of humanity's oldest and most profound questions: are we alone? For decades, the field of astrobiology and initiatives like SETI, the search for extraterrestrial intelligence, have operated on a fundamental assumption that the laws of physics and chemistry we observe here are universal constants. We search for water on Mars because water is our universal solvent. We look for planets within the habitable zone around their stars, where temperatures could allow for liquid water, because we assume that life, like us, will be carbon-based and require that specific energy gradient. This search is already monumentally difficult within our single universe, scanning the vast, silent darkness for a signal that may never come. But the multiverse concept explodes this framework into something infinitely more complex and wondrously strange. If the multiverse is real, then the probability of life existing somewhere doesn't just increase, it skyrockets toward a near certainty. An infinite ensemble of universes means an infinite number of chances for the random, miraculous combination of chemistry and conditions that sparks life to occur. The daunting odds that once made our existence feel like a lonely fluke are completely overturned. In a cosmic landscape of infinite possibilities, life is not a miracle, it is an inevitability. We should expect a cosmos teeming with life, a thriving, buzzing multiverse of consciousness. This is an incredibly optimistic and energizing vision for the search for extraterrestrial intelligence. suggesting that the great silence we've experienced so far might simply be a matter of scale and time, not absence. However, this thrilling prospect comes with a daunting caveat that completely redefines what we might be looking for. The very mechanism that makes life statistically inevitable, the variation of physical laws from one universe to the next, also means that the vast majority of life will be utterly unrecognizable to us. Our template for life is based on a very specific and perhaps very parochial set of rules. We require atoms to be stable and elements like carbon to have the specific chemical properties they do. But what if you were in a universe where the strong nuclear force was slightly stronger, allowing for stable elements that don't even exist in our periodic table? Life there might be based on a completely different element, with a biology we cannot even begin to model. What if the fundamental forces are so different that matter can't even coalesce into planets and stars, but life emerges in the swirling, complex plasma of a nebula? Or in a universe with more spatial dimensions, where beings navigate a reality we can't even visualize? The diversity of life across the multiverse could be so vast that our current search strategies, which look for signatures like oxygen atmospheres or radio waves, might be akin to a deep-sea creature that only recognizes other creatures that glow in the dark, missing an entire ecosystem thriving in the shadows. This doesn't render our search futile. Instead, it forces a revolutionary expansion of our imagination. Astrobiology must become a science of the possible, not just the familiar. It encourages scientists to model universes with different constants to see which ones could still permit complex, self-organizing structures, even if they look nothing like life on Earth. Perhaps a form of information processing, a kind of cosmic consciousness, could emerge in the gravitational dance between black holes or in the complex magnetic fields of a neutron star. Furthermore, the multiverse might even provide new avenues for detection. Some theories suggest that if our universe collided with a neighboring bubble universe in the distant past, it could have left an imprint on the cosmic microwave background, a bruise on the sky that would be the first tangible evidence of another cosmos. While finding direct evidence of life in another universe remains a fantasy with our current understanding, the multiverse framework shifts the goalposts, transforming the quest from a search for other Earths to a much grander ambition: to understand the universal principles of complexity and emergence that could give rise to life in any of its infinite alien forms. So how do we translate these mind-bending concepts from the abstract realm of theoretical physics into something tangible and exciting for a new generation of thinkers? The key lies not in diluting the ideas, but in crafting the right bridges of understanding using clear analogies, engaging visualizations, and relatable stories that anchor the fantastic to the familiar. The most effective educators recognize that to teach the multiverse, you must first invite students on an adventure, transforming them from passive listeners into active explorers of reality's deepest mysteries. It's about creating a sense of wonder and possibility, showing that these are not settled facts to be memorized, but thrilling frontiers to be investigated. One of the most powerful tools in this endeavor is the thoughtful use of analogy. Instead of starting with complex equations, you might begin with a simple, relatable scenario. Imagine a vast library, you could say, one that contains not just every book that has ever been written, but every book that could ever be written. Our universe is just one book on one shelf in this infinite library of Babel. Some books are almost identical to ours, differing by a single word or a misplaced comma. Others are written in completely different languages or describe realities with two moons, purple grass, or where you never made that one embarrassing mistake in 8th grade. This literary metaphor, inspired by Jorge Luis Borges, makes the abstract concept of possibility space immediately graspable. For a more technological generation, the analogy of a vast cosmic video game is incredibly effective. Our universe is one saved game file with a specific set of rules and parameters. The multiverse is the game's main menu, offering an endless list of other save files where the difficulty settings, character choices, and even the fundamental laws of the game world are completely different. These analogies don't explain the mechanics of inflation or decoherence, but they provide a crucial conceptual foothold, a framework onto which the deeper science can later be attached. Beyond analogy, interactive thought experiments are essential for making these ideas personal. While Schrödinger's cat is a classic, it can be modernized and made more engaging. Instead of a cat in a box, challenge students to think about their own lives. Present them with a simple choice. Raise your hand if you would choose a guaranteed $500 or take a 50-50 chance at winning $2,000. After the choice is made, guide them through the many worlds interpretation. Explain that in that moment of decision, the classroom didn't just split into two groups, the entire universe split into two branches. In one reality, everyone in this room chose the safe bet. In another, identical reality, everyone chose the gamble. And in both, each version of you is utterly convinced they made the only real choice. This personalization transforms the theory from a distant curiosity into an immediate and almost intimate experience, prompting profound questions about identity and free will that blend physics with philosophy in the most compelling way. The most successful educational strategies are inherently interdisciplinary, weaving together threads from science, philosophy, literature, and art. A lesson on the multiverse is the perfect opportunity to show that knowledge isn't confined to separate boxes. You can discuss the quantum physics of Hugh Everett, then read a short story by Ted Chiang that explores its emotional consequences. You can analyze the cosmological models of Alan Guth, then examine how ancient Hindu scriptures described countless cyclical universes long before modern science. This approach demonstrates that big questions require big thinking from all angles. It validates different types of minds: the mathematical thinker, the philosophical debater, the creative storyteller, and shows them that they all have a vital role to play in unraveling the cosmos's greatest mysteries. By making the multiverse a collaborative puzzle rather than a settled doctrine, we empower students to not just learn about science, but to actually think like scientists, embracing curiosity, tolerating uncertainty, and daring to imagine the impossible. The goal isn't to convince them that the multiverse is real, but to equip them with the intellectual tools to understand the arguments, appreciate the evidence, and eventually, perhaps, contribute to the conversation themselves. But this branching reality forces us to confront one of the most intimate and perplexing questions of all. If countless versions of you are living out every possible life path across the multiverse, do they all share your awareness? Is there a single stream of consciousness that somehow splits and experiences all possibilities simultaneously? Or does each new branch instantly create a completely separate, isolated conscious being that merely shares your memories up to the point of divergence? This isn't just a whimsical query. It strikes at the very heart of what we mean by the self and the nature of subjective experience. To even approach an answer, we have to venture into some of the most speculative but fascinating theories of consciousness itself, frameworks that attempt to explain how subjective awareness arises from physical matter. One compelling perspective comes from a theory known as Integrated Information Theory, or EIT. Developed by neuroscientist Giulio Tononi, IIT proposes that consciousness is not a separate, magical substance, but an intrinsic property of any sufficiently complex system that can integrate information in a specific way. The theory introduces a measure called phi, which quantifies the degree of integration within a system. A high phi value suggests a rich, unified conscious experience, while a low phi indicates little to no consciousness. In the context of the multiverse, this theory offers a startlingly clear, if disorienting, answer. At the moment a universe branches due to a quantum event, the physical system that is your brain, a vast network of neurons, would also branch. According to IIT, each of these new, separate physical systems would then generate its own, entirely distinct conscious experience from that moment forward. There is no single you that splits and feels both outcomes. Instead, one conscious you continues in the universe where the quantum coin landed heads, and a completely new, separate conscious being, with all your memories and an identical brain state, winks into existence in the universe where it landed tails. From its perspective, it has always been you, and it will never know the difference. This view suggests that consciousness is not a thread that is pulled apart, but is rather a flame that is constantly being lit anew on every branch of the cosmic tree. An even more radical viewpoint comes from the ancient philosophy of panpsychism, which is experiencing a modern revival among some philosophers and scientists. Panpsychism posits that consciousness is a fundamental property of the universe, much like mass or charge, and is present to some degree in all things. From this perspective, an electron might have a tiny, simple form of experience, and a human brain, with its immense complexity, has a rich, vivid, conscious experience. When applied to the multiverse, panpsychism suggests that every single branch, every possible version of reality, is inherently conscious because consciousness is woven into the fabric of space-time itself. Every alternate version of you is just as conscious as you are right now, because consciousness is not an emergent property that appears only under specific conditions. It is a basic feature of existence. This doesn't mean they share your specific awareness. Each one is its own isolated center of experience, but they all partake in the same fundamental property of being conscious. This view completely flattens the hierarchy of existence, suggesting that there is no original you, just a near-infinite collection of conscious beings who all legitimately and equally lay claim to having started from the same point. These theories, while intellectually thrilling, immediately plunge us into a profound ethical and existential abyss. If every decision creates a new, fully conscious being who will live out the consequences of that choice, then the weight of our actions becomes unimaginably heavy. The version of you that makes a cruel remark in a moment of anger doesn't just create a timeline where relationships are damaged. It creates a conscious being who is now condemned to live with that regret and its ripple effects. Conversely, every act of kindness creates a conscious being who gets to experience a reality where that generosity flourished. This isn't about parallel lives that you can dismiss as not real. From the perspective of each consciousness, their reality is the only one they will ever know. This framework could be seen as the ultimate argument for compassion and mindfulness, as every single choice we make is quite literally an act of world-building, bringing into existence a new conscious experience that will be defined by that very decision. It transforms ethics from a personal code into a cosmic responsibility, where our smallest actions resonate across the multiverse by creating new sentient beings to experience their consequences. While we may never have empirical proof for these ideas, they serve as powerful thought experiments that challenge our most basic assumptions about identity, choice, and our place in a reality of infinite possibilities. While the idea of infinite universes might seem like it should solve all our problems, the harsh truth is that the multiverse offers no practical escape from the economic and resource challenges we face right here in our own reality. Because these other universes are, by their very definition, causally disconnected from our own, separated by impassable oceans of inflating space, or existing in branching timelines we can never access. They are utterly irrelevant to our material needs. We cannot mine for minerals on an Earth in another dimension. We cannot siphon energy from a universe with different physical laws, and we cannot import food from a reality where our doppelganger made better agricultural policies. Any discussion of directly harnessing the multiverse for resources is, for now and likely forever, pure science fiction, a fantasy that distracts from the urgent need to manage the one finite planet we actually inhabit. However, this doesn't mean the concept is useless to fields like economics and resource management. Far from it. The multiverse provides an incredibly powerful metaphorical toolkit, a way to reframe our thinking about risk, decision-making, and the paths not taken. Economists and strategists already use a form of this thinking when they build complex models involving parallel scenarios. Imagine a central bank trying to decide whether to raise or lower interest rates. Their analysts will run dozens of simulations, creating what is essentially a set of parallel economic universes. In one model, the rate hike cools inflation without triggering a recession. In another, slightly different model, it leads to a spike in unemployment and a market crash. Each simulation is a self-contained, what-if scenario, a branch on a decision tree that allows policymakers to visualize potential futures and weigh the probable outcomes of their choices, much like a conscious observer navigating the branching paths of the quantum many worlds interpretation. This isn't just number crunching, it's a formalized method of leveraging the power of possibility, of learning from worlds that never were to make better decisions in the world that is. This metaphorical approach extends brilliantly into the realm of personal finance and investment. The concept of opportunity cost, the value of the next best alternative you give up when you make a choice, is a classic economic principle. The multiverse frame makes this idea visceral. When you choose to invest $1,000 in a conservative bond fund, there is a parallel economic reality where you invested that same money in a volatile tech stock that skyrocketed. Conversely, there's another where that tech stock crashed and burned. Acknowledging these phantom realities doesn't mean regretting your choice. It means understanding that every decision closes some doors while opening others. This mindset encourages a more mature and nuanced approach to risk, helping us to appreciate the path we're on without being paralyzed by the infinite what-ifs that branch out from every moment. It teaches us that we can't actualize every possible future, so we must choose wisely and commit to the consequences in our own timeline. On a global scale, the multiverse metaphor becomes a stark warning against irreversible actions. Consider our approach to climate change or biodiversity loss. We are, in effect, running a dangerous, real-world experiment with our planet's life support systems. There might be a universe where we transitioned to green energy decades ago and stabilized the climate. There is certainly one where we did nothing and faced civilization-altering collapse. Our universe is currently somewhere in between. The multiverse concept reminds us that we don't get to jump to a better branch if we ruin this one. We are stuck with the outcomes of the choices we make in this single, irreplaceable reality. This makes a powerful ethical case for the precautionary principle, the idea that we should avoid actions that carry a risk of severe or irreversible harm, even if some models suggest they might be safe. We don't have the luxury of testing our policies in a dozen parallel worlds and then cherry-picking the best result. We have to get it right, or at least not catastrophically wrong the first time. And while the notion of extracting energy or matter from other universes remains firmly in the domain of theoretical physics and comic books, it does fuel a valuable form of speculative thinking that can lead to real innovation. The very act of asking an outrageous question like, Could we ever tap into the zero-point energy of the quantum vacuum? Or what if we could access a universe where the cosmological constant is different? Forces scientists and engineers to stretch the boundaries of known physics. While the original goal may be unattainable, the journey toward it can uncover new principles, new materials, or new energy conversion techniques that have profound practical applications in our own world. The quest for a warp drive gave us a deeper understanding of general relativity. The dream of cold fusion advanced materials science. In this way, the multiverse acts as a cosmic muse, inspiring a kind of boundless creativity that, while aimed at the impossible, often lands on breakthroughs that reshape the possible, reminding us that the most valuable resource we can ever tap into is not in another dimension, but right between our ears, the limitless power of the human imagination to ask, what if? While the equations of physics and the debates of philosophers can make the multiverse feel like a distant, abstract concept, there is one place where millions of people are already actively exploring its implications firsthand: the digital worlds of video games and virtual reality. This interactive medium has become a powerful playground for experiencing multiverse principles not as a theory, but as a lived, emotional journey. Games are uniquely equipped to tackle these ideas because they are built on the very mechanics of choice and consequence, allowing players to become the conscious agents navigating a branching tree of possibilities. Unlike passive media like film or books, a game doesn't just tell you a story about alternate realities. It makes you the protagonist who creates them with every decision you make, no matter how small. Consider a title like The Stanley Parable, a masterpiece of meta-commentary on choice, agency, and narrative itself. On the surface, it's a simple game about an office worker following instructions. But it quickly devolves into a hilarious and deeply existential exploration of the very nature of video game narratives. The omnipresent narrator dictates a path for Stanley, but the player is free to disobey, to open the wrong door, to take the stairs instead of the elevator. Each act of defiance creates a new, often absurd, branching storyline. One path might lead to a serene museum about the game itself, another to a frantic countdown to destruction, and another to a simple, beautiful broom closet that the narrator desperately tries to lure you out of. The Stanley Parable is less a game about a multiverse and more a game that is a multiverse, laying bare the architecture of choice and making the player hyper-aware of the invisible walls and possibilities within a simulated reality. It brilliantly satirizes our desire for freedom while questioning whether any choice within a predetermined system can ever be truly free. A poignant metaphor for the philosophical debates surrounding determinism and free will in a quantum-branching cosmos. For a more narrative-driven and emotionally charged experience, few games are as potent as BioShock Infinite. This game doesn't just feature alternate timelines. Its entire plot is a thrilling and tragic rollercoaster ride through them. The protagonist, Booker DeWitt, and his companion, Elizabeth, who possesses the ability to tear open tears in reality, literally step between different versions of the floating city of Columbia. In one moment, you might be in a universe under attack, and in the next, you step through a rift into a nearly identical version of the same city where a vibrant parade is underway, the conflict having never happened. This isn't just a visual trick. It's core to the game's themes of constants and variables, the idea that certain pivotal events are fixed points across all realities, while smaller details can vary wildly. The game's mind-bending conclusion, which involves drowning Booker before the choice that splits the timelines can even occur, is a stunning narrative expression of trying to collapse a probability wave to erase a future of infinite pain. It translates the abstract quantum concept of superposition and collapse into a powerful, personal story about sacrifice, redemption, and the unbearable weight of infinite possibility. What makes these interactive experiences so transformative is their ability to generate a form of embodied cognition. You don't just intellectually understand the concept of branching timelines. You feel it in your gut when you hesitate before a dialogue wheel in a game like Mass Effect, knowing your response will permanently alter your relationship with a character. You experience the paranoia of a permadeath mechanic in a roguelike game like Hades, where each failed escape attempt from the underworld is framed not as a failure, but as a learning experience in a slightly different iteration of the story, with the protagonist Zagreus slowly piecing together the truth of his family across countless cycles. Virtual reality amplifies this even further, placing you entirely inside the alternate world and making the dissociation between your real body and your digital self even more pronounced, deepening the emotional and philosophical impact. This blurring of lines is where entertainment transcends into genuine philosophical exploration. These games serve as modern-day parables, safe sandboxes where we can experiment with identity, morality, and consequence without real-world risk. They allow us to ask ourselves difficult questions. If I could reload a save file after making a terrible moral choice, does that diminish the gravity of that choice? Is the version of me that chose to be a hero in one playthrough more authentically me than the version that chose to be a villain in another? By making us active participants in these narratives, games foster a unique form of empathy and introspection, proving that the most compelling way to understand the multiverse might not be through a telescope or a particle accelerator, but through a controller or a VR headset, one consequential choice at a time. The quest to move the multiverse from captivating speculation to established science is driving some of the most ambitious and creative research in modern physics. While we may never directly peer into another universe, scientists are devising ingenious methods to hunt for its faint, indirect signatures, cosmic fingerprints left on our own reality. One of the most promising arenas for this search is the study of the universe's very first moments, using the cosmos itself as a giant particle accelerator. The theory of cosmic inflation predicts that the rapid expansion of the early universe would have generated a background sea of gravitational waves, ripples in the fabric of spacetime. The specific pattern and strength of these primordial waves, if we can detect them, could tell us crucial details about the energy scales involved in inflation, potentially offering clues about whether the process is eternal and capable of generating a multiverse. Experiments are already underway to look for the imprint of these waves on the cosmic microwave background radiation, the afterglow of the Big Bang. While definitive proof has remained elusive so far, next-generation observatories, like the proposed Light-Bird satellite or more advanced ground-based telescopes, are being designed with the sensitivity to either find this signal or rule out a broad class of inflationary models, bringing us significantly closer to understanding the conditions that might spawn other universes. Beyond the vast cosmic horizon, other clues might be hiding in the bizarre and counterintuitive realm of the very small. Quantum mechanics, the source of the many worlds interpretation itself, could provide a testing ground through increasingly sophisticated experiments in quantum entanglement and superposition. Researchers are pushing the boundaries of what we can measure, attempting to create larger and larger quantum systems that remain in a coherent superposition. The goal is to probe the exact point where the quantum world gives way to the classical reality we experience. Does a conscious observer truly cause a wave function to collapse, as the Copenhagen interpretation suggests, or does the universe simply branch as Everett proposed? While we cannot yet follow that branch, we can design experiments that test the limits of the theory, searching for any anomalies or deviations that might point toward a deeper mechanism at play. Some physicists are even exploring the potential for faint, residual interactions between branches, a hypothetical phenomenon that, while considered an extreme long shot, could theoretically leave a detectable, if incredibly subtle, trace. On the theoretical front, the work is equally intense, focused on refining the very frameworks that predict a multiverse in the first place. For cosmic inflation, the challenge is to move from the general idea to a specific, definitive model. The original theory proposed by Alan Guth had a known problem: it didn't successfully transition to the hot Big Bang phase we observe. Modern work involves developing models of slow-roll inflation or hybrid inflation that can not only explain the initial rapid expansion, but also naturally and consistently end in a way that produces a universe like ours. Each of these models makes slightly different predictions about the patterns we should see in the distribution of galaxies and the cosmic microwave background. By comparing these precise theoretical predictions with ever more accurate observational data from missions like the James Webb Space Telescope, cosmologists are engaged in a process of elimination, slowly winnowing down the vast garden of inflationary possibilities to see which, if any, are true, and whether those true models inherently lead to a multiverse. Simultaneously, string theorists are grappling with the daunting complexity of the string landscape. The central challenge here is not just to prove that the 10 to the 500th power possible universes exist, but to develop a convincing measure to make statistical predictions. This goes back to the fundamental measure problem. If an infinite number of universes exist, how do we determine what a typical universe looks like? Current research involves applying advanced mathematics from probability theory and complex systems to find a unique and well-motivated way to count these universes. The aim is to be able to say with confidence that observers like us should expect to find ourselves in a universe with a cosmological constant of a certain value. If such a measure can be found and it successfully predicts the constants we observe, it would provide incredibly strong, albeit indirect, support for the multiverse hypothesis. It would show that our universe is not a bizarre outlier, but a statistically likely address for conscious life within a much larger cosmic metropolis. This multi-pronged attack, using deep space observatories, quantum labs, and abstract mathematics, demonstrates that the scientific pursuit of the multiverse is far from a passive philosophical exercise. It is an active, rigorous, and empirically grounded endeavor. Researchers are not simply waiting for proof to arrive. They are building the tools, both physical and intellectual, to go out and find it. They are defining what evidence would look like, what would constitute a successful test, and what would force us to abandon the idea altogether. This process may take decades, and the answers may be far stranger than we can currently imagine. But the journey itself is refining our understanding of the fundamental laws of nature, pushing the limits of our technology, and ensuring that our search for our place in the cosmos is guided by the most powerful tool we have, the scientific method itself. Yet for all its grandeur and explanatory appeal, the multiverse concept is far from universally accepted within the scientific community. A chorus of prominent and respected voices raises serious objections, arguing that this dazzling vision of infinite realities may be leading us down a philosophical dead end rather than toward a deeper understanding of the cosmos. At the forefront of this skeptical camp is physicist Paul Steinhardt, a key architect of the original inflationary theory who has since become one of its most formidable critics. Steinhardt's primary objection is not with the mathematics itself, but with what he sees as a catastrophic retreat from the foundational principles of the scientific method. He argues that a theory which posits the existence of countless other universes, forever beyond our observational reach, effectively places itself in a protected zone where it can never be tested, falsified, or verified. If no conceivable observation could ever prove the theory wrong, then in what sense is it actually science? Steinhardt fears that accepting the multiverse moves cosmology from the realm of empirical inquiry into the domain of metaphysics, transforming it from an evidence-based discipline into a form of modern mythology, elegant and imaginative but ultimately untestable and therefore unscientific. Driven by this critique, Steinhardt has devoted much of his career to developing and championing a compelling alternative cyclical cosmology. This model proposes that the universe undergoes an endless sequence of cosmic epochs, each beginning with a big bang and ending in a big crunch, followed by a rebirth into a new expanding phase. In this view, the fine-tuning of our universe isn't explained by an infinite number of separate realities, but by an infinite number of cycles within a single reality. Over countless iterations, the physical constants could have been gradually shaped and smoothed into their life-permitting values, much like a beach pebble is worn smooth by endless waves. This cyclical model aims to solve the same puzzles as the multiverse: the flatness, the uniformity, the fine-tuning, but it does so while keeping all the action within our one observable cosmos, a cosmos that could, in principle, bear scars or patterns from its previous cycles that we might one day detect. For Steinhardt, this is a more scientifically responsible path, offering a vision that is just as awe-inspiring as the multiverse, but remains firmly grounded in the possibility of empirical verification. Beyond the issue of testability, other critics worry about the psychological and philosophical impact of the multiverse idea on the scientific endeavor itself. They fear it acts as a conversation stopper, an intellectual surrender that discourages the search for a more fundamental and elegant theory. The great mystery of why our universe's constants are so perfectly tuned for life is simply explained away as a statistical fluke in a cosmic lottery. This, some argue, could create a generation of physicists who are content with shallow explanations, who no longer ask why the laws of physics are what they are because the answer is always, they just are in this branch. It risks halting the search for a truly profound underlying principle, a unique, compelling theory that could explain our universe's properties from first principles, without needing an infinity of unseen worlds to make the statistics work out. This isn't just a matter of philosophy, it guides funding and research priorities. Why invest immense resources into a decades-long search for a deeper theory of everything if we can simply attribute every oddity to the luck of the draw in a multiverse? This internal critique is essential for the health of cosmology. It represents the vital scientific principle of skepticism, the engine that has driven progress for centuries by constantly challenging established ideas and demanding rigorous standards of proof. The debate between multiverse proponents and their critics is not a sign of a field in crisis, but rather a sign of a field vibrantly alive, wrestling with its own limits and methodologies. Engaging seriously with these counterarguments doesn't weaken the multiverse hypothesis. It strengthens the entire discourse by forcing it to be more precise, more humble, and more creative in its quest for answers. It ensures that our wonder at the cosmos is always tempered by a disciplined commitment to truth, reminding us that the most exciting ideas in science are those that can withstand the fire of reasoned doubt and emerge not just unscathed but refined. Now, as we venture even further into the possibilities of the multiverse, we encounter a powerful ally in our quest for understanding, one that is not born from the cosmos but from our own ingenuity. Artificial intelligence is rapidly becoming an indispensable partner in this exploration, offering a set of tools that can navigate complexities far beyond the reach of the human mind alone. The sheer scale of the calculations required to model even a single inflationary bubble universe or to map the vast landscape of string theory is so immense that it would take conventional computers longer than the current age of the universe to complete them. This is where machine learning steps in, not as a replacement for human curiosity, but as a force multiplier for our intellect. These advanced algorithms can be trained on known physical laws and then set loose to simulate scenarios that are otherwise computationally intractable, searching through quintillions of possibilities to find those rare configurations that could lead to a stable, life-supporting cosmos like our own. They act as digital prospectors, sifting through an infinite desert of mathematical possibilities to find the few tiny nuggets of gold. One of the most exciting applications lies in the analysis of massive cosmological datasets. Our telescopes, like the James Webb Space Telescope and observatories mapping the cosmic microwave background, are collecting petabytes of information about the structure and history of our universe. Hidden within that data could be subtle anomalies, a strange pattern in the microwave background, an unexpected distribution of galaxies that might be the faint, ghostly imprint of a collision with another bubble universe in the distant past. Finding such a signal would be like looking for a single specific grain of sand on all the beaches of Earth. AI systems, with their unparalleled pattern recognition capabilities, are uniquely suited to this task. They can process these enormous datasets, filtering out noise and identifying statistical irregularities that might escape human notice, providing us with potential, albeit indirect, evidence for a multiverse and guiding physicists toward the most promising theoretical models. This partnership between AI and cosmology naturally leads us to a fascinating and recursive idea. If artificial intelligence can help us simulate and understand multiverses, could it be that our own reality is itself a form of simulation? This is the core of the simulation hypothesis, a concept that has moved from science fiction into serious philosophical debate. The argument, in its simplest form, suggests that if a civilization ever reaches a level of technological maturity capable of creating incredibly detailed, conscious simulations of reality, then the number of simulated beings would eventually vastly outnumber the beings in the original, base reality. Therefore, statistically, it is more likely that we are living in one of those simulations than in the original. From this perspective, the multiverse takes on a new character. It might not be a fundamental feature of nature, but a feature of a computational process. Each universe could be a separate simulation running on some advanced civilization's computer, each with its own slightly different initial settings and physical laws. The fine-tuning of our universe wouldn't be a lucky accident or a statistical necessity, but simply the result of a programmer's choice or a random number generator in a cosmic-level computer program. This doesn't just change how we think about the cosmos, it changes how we might study it. A growing field of inquiry known as digital physics or the computational universe theory proposes that the underlying fabric of reality might not be material but informational. In this view, the universe is fundamentally a vast computation, and the laws of physics are the algorithms that govern how information is processed and transformed. From this vantage point, the quest to discover a theory of everything becomes synonymous with the quest to crack the source code of the universe. AI could play a crucial role in this, not just by analyzing data from the outside, but by helping us reverse engineer the possible rules of the system from within. Could we one day run experiments that look for signs of computational efficiency or lower-level resolution in the laws of physics, potential evidence that we are in a constructed reality? It's a dizzying thought, but it demonstrates how AI is not just a tool for calculation but a catalyst for a profound paradigm shift, blurring the lines between physics, computer science, and philosophy, and pushing our investigation of the multiverse into realms we are only beginning to imagine. This idea of infinite parallel realities has done more than just revolutionize physics. It has quietly seeped into the very bedrock of our modern culture, reshaping how we think about everything from art and ethics to our most personal daily choices. It acts as a powerful cultural metaphor, a new lens through which we view the human experience, encouraging a radical openness to multiple perspectives and a comfort with ambiguity that feels uniquely suited to our complex, interconnected age. In a world that often demands black and white answers, the multiverse offers a shade of gray that is not about uncertainty, but about possibility, a mindset that values what could be over what simply is. We see this shift most vividly in the stories we tell ourselves. The explosion of multiverse narratives in film, television, and literature isn't just a passing trend. It's a cultural response to a newfound awareness of life's branching pathways. These stories provide a safe space to explore our deepest anxieties about regret and identity. When we watch a character confront a version of themselves who made a different choice, we are ultimately holding up a mirror to our own lives. It allows us to ask ourselves difficult questions in a hypothetical space. What if I had taken that job? What if I had spoken up in that meeting? What if I had moved to a different city? By externalizing these internal doubts onto alternate selves, the multiverse narrative gives us a vocabulary to process our own regrets without being paralyzed by them. It reframes the concept of a mistake not as a permanent failure on a single, linear path, but as one thread in a vast tapestry of potential lives, each with its own value and dignity. This can be incredibly liberating, reducing the weight of anxiety and allowing for a more compassionate view of our own past decisions and those of others. This cultural framework naturally fosters a greater sense of empathy and tolerance on a societal level. If we truly entertain the idea that infinite variations of people and perspectives exist across the multiverse, it becomes much harder to cling to a rigid, absolutist view of the world. It challenges the notion that there is one single, objectively correct way to live, love, or believe. Recognizing that a different set of circumstances could have led anyone, including ourselves, down a completely different path encourages us to withhold judgment and approach others with curiosity rather than condemnation. This doesn't mean abandoning moral principles, but rather understanding that our specific viewpoint is contingent on our unique position in a much larger web of possibility. In a time of intense social and political polarization, the multiverse metaphor, perhaps unconsciously, promotes a form of intellectual humility, reminding us that our truth is not the only truth, and that other valid, coherent realities can exist alongside our own. This embrace of possibility over certainty also serves as a powerful engine for creativity and innovation. The multiverse is the ultimate what-if scenario, and this question is the lifeblood of artistic and scientific breakthroughs. It encourages divergent thinking, the ability to generate many different ideas and explore numerous solutions to a problem. An architect might design a building by considering how it would function in a dozen different climatic realities. A software developer might stress test code by imagining how it would perform under every conceivable user error. An entrepreneur might brainstorm a business plan by envisioning a multitude of potential market futures. The multiverse mindset is a direct antidote to rigid, linear thinking, training our brains to break free from conventional patterns and explore a wider landscape of ideas. It tells us that no door is permanently closed, no idea is too outlandish, because in the vast expanse of possibility, even the most unlikely scenario has a home. Ultimately, the journey of the multiverse from an esoteric scientific hypothesis to a widespread cultural touchstone is a testament to humanity's endless desire to find meaning in the cosmos. It shows how a scientific concept, when it is powerful enough, can escape the confines of academic journals and laboratories to become a shared story, a new mythology for a technological age. It provides a framework that is both scientifically grounded and spiritually expansive, offering a sense of wonder that doesn't require a divine architect, but instead finds majesty in the sheer, generative abundance of nature itself. This idea reflects our contemporary worldview, a perspective that is more global, more interconnected, and more comfortable with complexity than ever before. And in turn, by giving us this new story, it actively shapes that worldview, encouraging us to live with more creativity, more compassion, and a greater appreciation for the breathtaking improbability of our own singular, precious existence in this particular branch of reality. For many people throughout history, the search for meaning and a sense of place within the cosmos has been guided by religious narrative stories of divine creation, purposeful design, and an afterlife that promises continuity beyond our mortal lives. These frameworks addressed a profound human need to feel that our existence is not a random accident, but part of a grand, intentional plan. The multiverse concept, emerging from the language of mathematics and physics, might seem like the antithesis of this spiritual yearning, a cold, mechanistic view that reduces us to mere statistical fluctuations. Yet for a growing number of individuals, it offers something entirely different, a modern, naturalistic mythology that fulfills those same deep existential cravings for wonder, purpose, and connection, but does so without invoking a supernatural architect. This framework finds its spiritual power not in a divine plan, but in the breathtaking grandeur of natural law itself. The idea that the fundamental constants of physics could have combined in an infinite number of ways, and that this process gave rise to a reality where beings like us can emerge to ponder it, inspires a form of awe that is every bit as profound as that felt in the grandest cathedral or under the starriest night sky. It replaces faith in a deity with faith in the incredible generative power of nature, a universe, or rather a multiverse, so vast and creative that it actualizes every possible form of existence. This perspective answers the question, why are we here? Not with because a God willed it, but with because the laws of reality make it inevitable that something as wondrous as a conscious mind would eventually arise to appreciate the wonder. It is a story of our origins that is both humbling and exalting. We are not the preordained center of a single creation, but we are a rare and beautiful expression of the cosmos's potential to know itself. This directly addresses the ancient human fear of mortality and the desire for a form of immortality. While the multiverse theory doesn't promise an afterlife for your individual soul, it offers a different kind of continuity. In an infinite tapestry of realities, every possible version of you gets to live out their life. The version of you that succumbed to an illness in this world might, in another branch, have received a timely diagnosis and lived to a ripe old age. The dreams you left unfulfilled here are being realized by other selves in other worlds. This isn't a personal resurrection, but it is a form of cosmic conservation where no possibility, no life, no love is ever truly lost. It all exists forever in the immutable structure of reality. This can be a profound source of comfort, reframing death not as an absolute end, but as a point of divergence after which your unique stream of consciousness may end, but the totality of your potential continues on without limit. It transforms the existential dread of finitude into a serene appreciation for the specific, singular journey you are on, while knowing that the broader story of all you could have been is eternally preserved. Furthermore, the multiverse fosters a powerful sense of connection that transcends the boundaries of our individual lives. If all possible realities exist, then we are all, in a cosmic sense, connected. Every person you meet and every being across the infinite cosmos is part of the same fundamental expression of existence. Your life is intimately intertwined with every other possible life because they all spring from the same quantum source, the same inflationary field, the same mathematical landscape. This creates a deep, ecological sense of belonging to a whole that is infinitely greater than the sum of its parts. It encourages a spirituality based on interdependence and wonder rather than dogma and division. You are not a separate soul awaiting judgment, but a unique manifestation of the universe, temporarily experiencing one thread of an infinite story. This perspective can inspire a profound ethical compassion, a recognition that the circumstances separating your life from another's, whether in this world or another, are ultimately contingent, and that in the grand scheme of things, we are all equally valid expressions of a single, astonishing reality. The multiverse, therefore, becomes more than a scientific hypothesis. For many, it is the foundation for a modern, rational, and deeply felt sense of the sacred. Now let's make this personal. I want you to pause for just a moment and picture something with me. You're walking down a quiet street you know well, maybe in your own neighborhood, when you turn a corner and suddenly come face to face with yourself. Not a mirror, not a trick of the light, but another version of you from another branch of the multiverse. This is the you that made a different choice at some pivotal moment, the you who took that job in another city, or who never met that one person who changed everything, or who pursued a forgotten childhood passion all the way to the finish line. What's the first thing that springs to your mind? Is it a question, a jolt of recognition, or perhaps a surge of curiosity about the life they've lived that you did not? This isn't just a daydream, it's a doorway into one of the most profound thought experiments the multiverse concept offers us. That initial moment of encounter pushes past abstract physics and into the core of our own identities. Would you even recognize this other self? Would their eyes hold the same light, the same scars, the same quiet victories or regrets? We often imagine our alternate selves as either wildly successful versions we envy or tragic figures we pity, but the reality suggested by the physics is far more subtle and far more interesting. They might be almost indistinguishable from you, their life differing in ways so tiny and yet so cumulative that they became a completely different person shaped by experiences you can't even imagine. The simple act of wondering what you would ask them, are you happy? Did you ever learn to play the piano? Is mom still with you? Forces you to clarify what truly matters to you in this life, in this timeline. It holds up a mirror to your own values, your own unmet ambitions, and the path you still have time to walk down. This exercise does more than just make the multiverse relatable. It transforms it from an external concept into an internal compass. By imagining the infinite variations of your own existence, you are not diminishing the importance of the choices you've made in this world. You are magnifying them. Every decision, from the monumental to the mundane, isn't just about shaping one life. It's about selecting which specific reality you continue to experience. The you in this universe chose to watch this video, to engage with these ideas, and that act of curiosity itself sets this branch apart from countless others where that didn't happen. You are, in a very real sense, the author of this particular narrative thread, continuously writing it with every action and every thought. So I'll leave you with this invitation to reflect, not as a conclusion, but as a beginning. Don't just think about what you would ask another you. Ask those questions of yourself right now. What does the life you're currently living say about who you are? And what might it inspire you to become? This is the true power of the multiverse idea. It's not about escaping into other realities, but about waking up to the breathtaking potential and responsibility inherent in this one. This profound shift in our cosmic perspective forces us to confront one of the most fundamental questions in all of human inquiry. What can we truly claim to know? The multiverse concept doesn't just challenge our understanding of physics. It launches a direct assault on the very foundations of knowledge itself, a field of philosophy known as epistemology. At the heart of the scientific method lies a simple but powerful principle. A good theory must be testable. It must make specific predictions that can, at least in principle, be verified or disproven through observation or experiment. This principle of empirical verification is the bedrock upon which we've built our modern understanding of the world, from the motion of planets to the behavior of subatomic particles. It's what separates scientific knowledge from mere speculation or faith. But the multiverse, by its very definition, seems to place a colossal obstacle in the path of this principle. If these other universes are truly causally disconnected from our own, separated by unimaginable distances, or existing in entirely separate dimensions of reality, then by what possible means could we ever gather evidence of their existence? How can we claim to know something that is, by its nature, permanently hidden from our view? This dilemma has sparked a fierce and necessary debate among philosophers of science, a debate that centers on the delicate balance between bold innovation and rigorous skepticism. On one side of this divide are those who argue that the multiverse, in its current form, represents a dangerous departure from empirical science. They contend that a theory which cannot be falsified, meaning no observation could ever prove it wrong, effectively places itself outside the bounds of scientific inquiry. If a theory is compatible with every possible state of affairs, then it doesn't actually explain anything at all. It becomes what critics call a theory of anything, an idea so flexible that it can accommodate any evidence, thereby rendering it scientifically useless. From this perspective, embracing the multiverse risks opening a Pandora's box, where the hard-won standards of evidence that have guided science for centuries are gradually eroded, making room for any number of untestable and ultimately meaningless speculations about the nature of reality. Yet, proponents of the multiverse offer a compelling counterargument. They suggest that while we may never directly observe another universe, we can still search for its indirect signatures, the cosmic fingerprints it might have left on our own reality. This is not without precedent in the history of science. We cannot, for example, directly observe a black hole's singularity, as it is hidden behind an event horizon from which no light can escape. But we accept their existence because of the overwhelming indirect evidence, the way they warp space-time, their powerful gravitational pull on stars, and the recent magnificent images of their shadow. In a similar vein, some models of cosmic inflation suggest that if our universe collided with a neighboring bubble in the distant past, that colossal event could have left a specific, anomalous pattern in the cosmic microwave background radiation, the afterglow of the Big Bang. Finding such a pattern wouldn't be a direct observation of another universe, but it would be a powerful, consistent piece of evidence that points toward a multiverse-generating mechanism. This approach shifts the goalposts of evidence, asking not for direct observation but for compelling inference based on the explanatory power of the theory. The true challenge, then, is to navigate a path between two equally unappealing extremes. On one hand, a rigid adherence to direct observation that might prematurely shut down some of our most profound and promising ideas about the cosmos, and on the other, an anything-goes approach that would allow untestable speculation to masquerade as science. This is not a new tension. Throughout history, many of our greatest scientific leaps have begun as seemingly untestable thought experiments. Ideas about atoms, continental drift, or the expansion of the universe that only later became subject to verification as our technology and understanding advanced. The multiverse may represent the next great frontier in this tradition, pushing us to expand our very definition of what constitutes evidence and to develop new, more sophisticated methods of testing our most ambitious ideas. It forces us to practice a delicate balancing act, fostering the creative, imaginative thinking that drives science forward while maintaining the rigorous, skeptical scrutiny that ensures we remain anchored to reality. In doing so, the multiverse doesn't just ask what exists, it asks how we can know what exists, challenging us to refine the tools of knowledge itself for a cosmos far stranger and more vast than we ever imagined. And so we find ourselves at the end of this incredible journey, having ventured from the quantum foam to the edges of the cosmic horizon, through the labyrinths of philosophy and the vibrant landscapes of human imagination. We've seen how a concept that once belonged solely to poets and mystics has been given mathematical form, not as a final answer, but as a profound and thrilling question mark etched onto our maps of reality. This exploration hasn't provided easy conclusions, and perhaps that is its greatest gift. The multiverse, in all its forms, is not a destination we arrive at, but a lens through which we can look at our own universe and our own lives with renewed wonder and a deeper sense of humility. This humility is perhaps the most valuable takeaway. The multiverse concept is a powerful reminder that our perspective is inherently and beautifully limited. We are finite beings peering out from a single planet, orbiting a typical star in one galaxy among trillions, which itself may be just one bubble in an infinite cosmic foam. Recognizing this isn't a call to insignificance, but an invitation to awe. It encourages us to hold our convictions lightly, to embrace the unknown, and to remain perpetually curious. The history of science is a story of us realizing, again and again, that the universe is far stranger and more magnificent than we had previously dared to dream. The multiverse is simply the latest and perhaps the grandest chapter in that ongoing story. Ultimately, the true power of this idea lies not in its potential to describe other worlds, but in its ability to reframe our experience of this one. It asks us to consider that every choice matters immensely, because it defines the unique reality we are actively creating, while simultaneously freeing us from the paralyzing weight of regret for paths not taken, knowing that in the vastness of existence, all possibilities find their expression. It's a framework that fosters both deep personal responsibility and a generous, expansive compassion for the journeys of others. So as we step away from this discussion and back into the tangible world of our daily lives, we can carry with us this dual sense of scale, the breathtaking grandeur of a possibly infinite cosmos, and the precious, singular value of our own conscious experience within it. The greatest mystery is not out there in some other dimension. It is right here in the fact that we can ponder these wonders at all. Thank you for exploring it with me. I'd love to hear your thoughts in the comments below. What possibility about parallel universes captivates you the most? Don't forget to like and subscribe if you enjoyed this journey. And until our next exploration, keep asking the big questions.